Hey everyone, welcome back to GitKon 2024. I'm Chris.
And I'm Allison. Whether you were here yesterday or just tuning in, we've got more insights, hands-on strategies, and fresh perspectives on DevEx, AI, and what's next for software development.
We've got a lot of exciting talks teed up today, so if you want to check out the full schedule, you can find it on gitkon.com.
Follow us on social so you don't miss any of today's live updates. And if you know colleagues or friends who'd enjoy the sessions, send them the stream link so they can join in too.
All right, let's dive into day 2 of GitKon 2024. Thanks for being here. Let's get started.
Hey, welcome everybody to our fireside chat. Thanks for joining us. I am Jeremy Castile. I lead product marketing here at GitKraken. And I am joined by Eric Amodio, our CTO and the creator of GitLens. Eric, thanks for joining me.
Yeah, thanks for having me.
Yeah.
GitKon crew.
Yes. Hey, so wanted to just start, could you tell us just a little bit about your background and sort of your role here at GitKraken?
Yeah, so I came on GitKraken about 3 years ago now with the acquisition of GitLens, the project I created probably 8 years ago now. It's just, dev tools have been a passion of mine for a long time, and just building tools for myself have been a passion for far, far longer. GitLens was born out of scratching my own itch, right? Like wanted to play with VS Code as it came out in its infancy. They shipped an extension API that we can actually play with, and I had teams that I was leading on, getting them onboarded to Git, and that was a challenge. So that's sort of where it was born out of. But it quickly started, from an experiment to, hey, what I do a lot as a senior dev is dive through history, come onto a code base, try to figure out why things are the way they are, and that was always a challenge, to dive through why things changed, or if I want to evolve this, making that better and learning, not repeating past mistakes. So that's why I wanted to create a tool that sort of brought up the knowledge that's locked in the code base to be accessible when you're writing new code. So that's where it came from, and continued grow to grow and snowball, and became far more successful than I would have ever expected from just something to work on nights and weekends and that sort of stuff. And then now taking it to a whole new level here today.
Yeah, so that's actually one of the things I wanted to ask you about GitLens, and I think people would be curious about. It's almost, I think, near 40 million installs. That's insane.
It is insane. Yeah, it is. It's definitely crazy. It's been a hell of a ride. The open source journey and sort of creating tools for free, it has both sides, pluses and minuses. Getting a lot of complaints from people on that sort of side is definitely challenging, but then there's a whole lot of positive constant reinforcement. But as a lot of open source maintainers know, it definitely can take its toll. Especially too, there's something that you created, you put out there. If there's a bug, if there's an issue, you just feel some level of responsibility to getting that resolved, and that becomes could become unhealthy. Now it's nice that I'm able to spend actual working hours working on it, and that sort of thing. So it's been a journey for sure.
Yeah, awesome. Okay, cool. So we want to chat about AI and developer experience. So wanted to ask you some questions around that. So from your perspective, tell us a little bit about the key ways that AI is being leveraged. We talked about a lot about the developer workflow. How is AI being leveraged to kind of help improve the developer workflow from your perspective?
Yeah, it's something that's continuing evolving and changing, and it's changing quite quickly as not only AI has gotten more capable of what it can handle and just being able to do more things, but it's also just permeating more. We've got tons more people thinking about how it can affect different areas. When it started, a lot of it was just getting better autocomplete where I'm typing, help me finish that. And we've come a long way from that autocomplete, and the autocomplete itself has gotten much richer and better, and the tools in that space continue to evolve and to some of them learning your style and your code base style and that sort of stuff. So like they become much more predictive. So in learning things across chain, like if I'm editing one thing in one file and I go into other files, so, keeping that context and like, meeting you where you are on that has been definitely interesting. But then taking that to sort of the next layer on being able to ask it to do more things, like, not just infer what I'm going to do, but I'm going to ask of, hey, finish this thing off, or like refactor this or change these sort of things, and it can make changes over that. So, GitHub shipped their Copilot edits very recently in VS Code and other places, and that's been a really interesting thing. Cursor's doing similar things in that. Augment is also doing interesting things around that angle. There's still an aspect of that right now you have to go, and I have to go to a chat and say that, do X, Y, and Z and drag in other contexts or that sort of thing. One of the things that I would love to see more of at some point, which is a much harder problem, is to, follow what I am doing and offer to not complete the line I'm on, but to complete the series of things. Like, I've started on this journey. Can you infer? Can you help and suggest where to go next? And go next even further than just, literally the next step in my, where my cursor is, which we're already doing, but bring that across. So
almost like predict what you're trying to do in a way.
Refactoring a method, well, go and find all the places where that method is used and offer to change them because the signature changed, or I added this thing here, and that sort of stuff. So, that stuff is, I know people are working on some of those sort of things, but I'm interested there because it's going to help, sort of keeps you in that flow better than, I've got to completely exit my coding and go to a chat. So there's some interesting things there. And then the other side is, completely like the agentic flow. I still can't get used to that word.
Yeah, I know.
But using software agents and to do that sort of thing. So like that one, you're not starting from the coding experience. You're starting from like an issue, a task, some level of context to get it to go and do that work. And there's some really interesting stuff coming along to like make that more accessible.
I think it feels like it's definitely going in very productive places.
Yeah, I mean, it has challenges for the industry and where we go with that, because it's going to impact, actual people. But I think it's also just, it's extremely exciting at the same time for, a dev can basically expand their capabilities and capacity, right? Because like if I'm, working on multiple different things, well, I can send this off, and if I can get the AI to add this simple bar to the feature or this other feature, I can send, kick these off in parallel. I can go to bed. Yeah, I can wake up and then come back and start running on that. And then continue, and then we can continue to iterate on that. And right now it is still early days, and the output is not what you would really want, but it's getting better in a lot of cases too. Even if its output isn't the goal, it's a good starting point to get you along that path. So,
it takes a little hand holding, but you can get down that path. Yeah. Okay, let me ask you about some of the potential downsides since you mentioned it. I mean, are there risks of over relying on AI? What are things that developers and teams should be aware of?
Yeah, I mean, there's lots of inherent risks in the fact that it's could be very inaccurate, right? It's AI models are still subject to their hallucinations and that sort of thing, but just they're trying to be helpful. And they're not perfect predictors. Humans aren't either. So like there's plenty of times you ask a dev to go and do this sort of thing and you don't get the output that you expected because it wasn't spec'd well enough and that sort of thing. So but there are definitely challenges. I think one of the bigger ones are just it's the trust of output. I think naturally humans are there's a little bit of deference of when things are, if your teammate says that, or if a super senior dev says it, right? Like then you're going to consider things differently,
maybe,
And one thing that we have historically shown is that we will defer to a machine as having far more context, data, or something, like it knows better than I do.
We just assume,
and we assume like these AIs are smart. They're not. They have a lot of context that they can draw from to help, but they're not intelligent at this stage. So deferring that and saying like, oh well, the output said that, it must be true, is one of the challenges. And that like as a more seasoned dev or more experienced in where you're asking it, because it's not even just your experience, it's just like what you're working in. Right? If you have experience in it, it's easy to sniff out or rectify those things where it's not the best option. But for more junior devs or devs that are working in something that they don't have prior experience in, it becomes fairly challenging, because it's, do I trust it? Like, can I trust it? Like,
well, I even saw that like with ChatGPT, and it's getting better at this, but like, in the work that I do, where I'll prompt, and then sometimes like if you ask it for like, cite that, where did you get this? That was kind of the first indicator for me that was like, whoa, some of the hallucinations, or like you can't always trust the output here.
And it like, it's this double-edged sword too, is because you can't necessarily trust it. A lot of these models almost have over-indexed on the human response. So if you go and push back on it, it's like, oh yeah, I was completely wrong. And like in a lot of cases, it's not completely wrong, but it hallucinated some part of that, or like it offered you three options, and two of them were fine, but the third one was just not there. And like sometimes if you just like, hey, can you go and like re-vet that, you sort of get a little bit better. But like there's also where it's like, oh, you said no, so we're going to say, oh yeah, no, those don't exist, we made it up. And it's like, that's equally bad.
That definitely seems risky, especially, if you're like maybe modifying a, like critical piece of code, and you're relying on, the AI to maybe help you out with some of that, and then it's like, there's layers of like, how much can I trust this thing? Can I trust what it's initially giving me? Can I trust the pushback that, I'm giving to it, and now it's giving back to me?
Yeah, and then some things, some of the later models have gotten better of like, kind of a little bit if you push back on showing your work or that sort of thing. Because like, one thing that a lot of people, or that I've seen and would like to do is like, help optimize, or like, is this algorithm going to perform, or that sort of stuff, is like, you're trying to write performant code and make sure that we're not creating issues there. They're typically pretty bad at some of that. They will offer things up that can actually make the performance significantly worse, or it's not considering. But like, sometimes if showing you work, it will actually start thinking through notation and when things are and that sort of stuff. But there's a lot that you can't really trust. When it would be more interesting is as these systems evolve, to be able to run and benchmark the actual code and changes, to say be able to run and vet that, and then feed that back into the model. Like it would be able to test that code, like run that unit test to see if the performance is worse or better, and that sort of thing. So like as these systems can get more connected to being able to run that code and be able to actually vet it that way, then you can hopefully get much more grounded responses. But they're still in the early days of getting that, but there's some interesting experiments going on to try to bring it to runnable stuff.
It's super interesting, and I think there's plenty of risks, based on sort of the conversation. Okay, cool. I want to ask you about, for developers who are kind of starting to, experiment with AI, what kind of like sort of advice, I guess, would you give them when they're starting down this path?
Yeah, I think that's a good point on the, the other side of risk is not taking advantage of it. Because, these tools, they have challenges. They're not like, they're not the hammer that's going to open, you're going to undo a screw with a hammer. So like they're not used for everything, but it's also not taking advantage and leaning into how these tools could be useful for you and your workflow to accelerate you is in my view, if you're not taking advantage of that, you will get left behind. These are tools that, if wielded well, can really accelerate.
And that's true for outside of development as well.
Yes.
I mean, for so many different areas.
Yeah, and I mean, I think there's because of the hallucinations and those sort of things, it can be viewed as a fad or something that's overhyped. And don't get me wrong, I'm sure there's a lot of overhype. I mean, there's plenty of overhype, but there is some real meat and value there. And it's like, to cut through that noise. It doesn't mean it's going to help you in every aspect or be right, but there's a lot of acceleration that you can take advantage of. And personally, I find it as a really invaluable tool. And it's an invaluable tool for learning, getting an answer, and helping accelerate. If I'm just want to iterate on an idea and want to just set off a wild prototype, if it gets me 20% down that road that I didn't do, and I wasn't gated by it, then it's really interesting.
Yeah, massive productivity booster. Yeah. So we chatted a little bit about this, but junior devs, senior devs, AI chatbots kind of in the middle, like where does that leave, junior devs, and are senior devs going to be relying more heavily on AI versus more junior developers?
Yeah. It's a hard one. I mean, it's a hard one to predict, as because things can change quickly, and prior, these early models from to 3 to GPT-4 and many of the things that have continued, right? Like we had these enormous exponential growth on the capabilities and that sort of stuff, and that's slowed a little bit, but maybe it resumes again. We'll see what the next gens when that happens, but it's hard to see what that trend is going to be like, because if these agents can get to getting better quality output, then it does get challenging to I'll spin up an agent to go do that work versus send it to a junior dev to go do that, and then you create the challenge of how are you actually going to grow devs to get to senior to be able to do that? And I mean, I don't have good answers right now, other than if you are starting out, leveraging the tools and being able to leverage and orchestrate the tools will put you ahead of a senior dev who's not going to take advantage of that. Yeah,
start using it.
It's try to take advantage of it, but it is challenging because without experience to lean on, it's hard to validate.
I mean, is there a scenario where it's it can help make the junior developer even that much more productive?
It definitely can. It's just the vetting and the quality is the challenge, right? Because if you can't say that output is good or bad, and you just trust it, well, there's challenges in there. But with enough testing set up, or guardrails that you have on the app and the things that you're doing, then hopefully you can sort of validate that. It may require more iterative loops that would lengthen things, but it still should be possible.
Okay, awesome. So one of the things I want to ask you about is analytics when it comes to activity. There's a ton of hype around this. There's a ton of different areas when it comes to productivity analytics, and we've talked about this a lot. I want to know your perspective on how does AI, what does it do for sort of whether it's productivity analytics or kind of software lifecycle analytics. Specifically, how does this help the developer?
Yeah,
or does it?
Yeah, I mean, I think it's the analytics side is the measurement of the output, but I think the AI is hopefully being able to tell us where the bottlenecks are, where we can deploy it more the whole point of like the analytics is to try to identify where there are gaps or challenges or bottlenecks in your life cycle, right? And so, we know that there are significant bottlenecks in general in a lot of groups, from the starting work to actually getting the code in a good place, because it's whether requirements are filled out enough detail, like if there's enough understanding and context to get started on something. And that's some area that we can start leveraging AI in more, is like having it analyze the issues, having it analyze given a set of rules that your team likes to have of requirements, look at that, look at this issue, is it actionable enough? Does it help with the brainstorming for who's ever building that out of what other things should you consider if you're going to implement this feature? What are our security implications on that sort of thing? So you can start preloading that, but it also could be just in time to dev went and grabbed this ticket, then they can work with the AI on flushing that out, making that more actionable than helping to code that. And if you spend more time on the front end too, you may be much more successful on getting an agent to do a portion of that work as well. And then being able to so if you can shorten that cycle of because if you can spend that time without having to pull in and going back and loop through other people, you're going to shorten your time there. And then same with the the coding time. There's a lot of coding tools and helping to actually generate the code in that sort of thing. And then the review side is another area where we're trying to spend a lot of to figure out of how AI can really help with bringing in extra context to not only help you pre-review your code before you even necessarily submit it for the PR. Make sure that it does meet the requirements, that it meets our quality gates, our security stuff, do other scans, and then when you get to the PR, that your teammates can bring in that other context and give you a better outline. I mean, one thing too is just AI is really good at writing. And I don't just mean code-wise, but so if it can summarize the set of changes, what you did, and some of your thought process from when you did the ideation at the front, if you can bring that in, summarize that down, consolidate it into, make it more concise, which AI is really good at as well, getting that PR so that someone else can get that context a lot easier to review the changes, and then, focusing on areas of code that they should review. And those, in theory, are really going to help those metrics. I think trying to analyze other than the throughput, it's really tricky at this stage to say how much AI helps certain metrics, right? Like, oh, did I write more lines of code faster? Well, maybe, but is that better output?
Yeah.
Well,
that's kind of what I'm wondering is we have tools to do that today, right? There are tools that do that. Does AI help improve that? Because sometimes you can game those metrics, or sometimes the metrics just don't represent the reality. Does AI, will it help that at all? Yeah, I mean,
I think it will help to a degree, but it also helps game.
Yeah, okay.
Right? Yeah. It's oh, hey, do this function, but make it really verbose.
Yeah.
I've added 300 lines of code. I mean, AI in general, in GitHub actually shipped a blog post very recently about some metrics, and the conciseness of code, it improved in their random testing that conciseness was better than that sort of thing. So
code quality type of a thing.
Yeah, they did a whole code quality report. I think it just came out very recently.
Okay.
And they were looking at many different axes on lines of code, but also how many lines were added to versus somebody doing the same task themselves, and that sort of stuff. So I mean in general, right, the less lines of code, the easier to review, maintain, and that sort of stuff. So that's sort of a good thing, but it's still hard to tell based on is that code still readable? Did it become more concise, but that readability take a hit? They also, in that study, they said that readability went up as well, and from that side.
Okay.
So it wasn't just it's cryptically concise. It was more concise but more consumable.
Yeah.
I mean that's something that's interesting, documentation is really good from that side too. But
well, one other thing on the analytics piece that I was curious about is like, is there an opportunity for like a better feedback loop for developers, like during a sprint or before like the project maybe gets off track or is delayed or something like that? Will AI help with any of that type of thing?
Yeah, I mean, I think that one's tricky to watch behavior, but I mean, I think we want to be able to see where bottlenecks are, and then if you're if it's waiting in review, basically make sure that like we can sort of encourage the team to look at this sort of stuff, break that down, tying it into also where you might get stuck on pieces, trying to help through that, but I think it's like it helps those top lines by allowing you to be more effective at the stages through that cycle, but it's the loops through they're basically more about bringing context in the right place, is to try to try to offer up and bring in extra context to when you're like starting the review, when you're doing the final stages of like, hey, I'm going to push this up, to bring that into that. So like, that sort of feedback loop through what your team thinks is important.
So, I mean, it sounds like, when you think about developer experience, a lot of it is, obviously, having all the right context, right? And it sounds like there's some opportunities there where AI can help. It's about like maybe reducing cognitive load, where you're not having to go and find all these different things. You're not having to switch. You can maybe stay longer in like that flow state. But there's opportunities for it to still get better, across that. Okay.
Yeah, I mean, I think one of the big benefits, right, like the I guess the sort of ultimate goal is to help, make sure the ultimate goal is just like get machines to write all the code, right? And you just tell it what you want to do. Oh, that's not the right thing. We'll do this one. And like you can just iterate.
So in that world, do software engineers become like product managers, or?
Probably. And I mean, I think we're still quite a distance from that, but that is like sort of the interesting end game, is where like the code generation is free, or the code generation is actually dynamic, where it's like doing it in real time. Like your UIs don't get pre-coded. It's based on the state, based on what you're looking at. Like, oh, well, you're doing this thing. Well, we're going to render a UI that makes sense right then, and it's not pre-done. And there's some really interesting stuff. Like there's the pre-rendered Doom, where there's no engine. It's just the AI as you're moving the keyboard, just auto-generating scenes.
Okay, so like as you're moving through a world,
it's just
it generates as you go based on dynamically how you're interacting. That's cool.
And there's no graphics engine, no nothing. It's just generating the pixels as you're moving, and it's kind of insane. Yeah. But prior to that, I actually lost my train.
I was just around like how AI is really helping to improve the developer experience, the context, the cognitive load.
Yeah, so the context piece I think is really important in the before the stage of the machines write it all, which is we've got time, but the is like one of the things in I'm old, so one of the things early was that you can build a lot by just keeping it all in your head, right? The systems weren't complex enough. I could literally keep the entire system in my head, so it's very easy to reason about and plan through. If I change this is going to affect this in the system and that sort of stuff. And we've, systems have gotten so complex that you can't reasonably keep that in your head. But AI can effectively keep it in its head. Yeah. I mean, it's not there perfectly by any stretch now, but it's getting a lot better to be able to have that context. And so you to be able to tap into that to say, if I push on this, well, this thing's going to happen over here, to leverage that, to not have to keep that. So it basically can bring you to, that one dev who used to be able to keep that stuff in your head still effectively do that by leveraging this tool.
Is there a good system for that today, that where it kind of knows the context of sort of like, let's say you have a massive distributed system and it.
Yeah, I mean, for actually getting the more running context and like how your system pieces come together, I haven't seen any good for that yet. But getting the context of like your repository, or even maybe a couple repositories to have that sort of broader context is definitely getting a lot better. And a lot of the models or not the models themselves, but a lot of the tools are diving deeper into indexing and taking context across the entire system and be able to say like, oh, if you change that here, what are the ripple effects, what this will change in the system, that sort of stuff. But it becomes a lot more interesting too, is to tie those into down the road of getting APM data of like, is this function run in production, how often does it hit, those sort of things, and sort of be able to tie that into the considerations that not only you as the dev need to have, but the AI would need to have when optimizing that or suggesting a change in there. Like if this function is going to get called 1 million times in production, you don't want that to be slow. And getting that more context pull in, like that's not stuff that we can continue have in our head, but we can sort of bring in more and have accessible to the models themselves.
Yeah, I could see how that could be a massive boost. Okay, cool. So last question. I want, if you can predict the future for us a little bit, 5 years, 10 years, give us a glimpse into where is all this going?
I mean, it's really hard to say, right? Like, we went through GPT-3, 4, 5, 4, whatever, right? Getting to this hugely step function of just like the increased capability. And now we're sort of like seemingly hitting a bit of a ceiling. It's not really a ceiling, but we have to think differently than just doing the same thing that got us the previous stages. So it's hard to predict like where the time frames will get to. But, at some point, and at some point, is leveraging agents a lot more, like that's coming soon, like that exists in forms already today, but being able to do a lot more in those agents and have them be more effective is just going to continue to come. So like there's aspects of it today, in my view,
agents
they're not
for
great.
Everything type of
just to do different work. I mean, right now a lot of the agent stuff in the app like is really cool from like the creation side of smaller things, greenfield. They do seem really well, these incredible demos and that sort of stuff. To me, it starts falling apart when it gets into like your more complex app and dealing with larger
but that's
code
the real
bases.
world.
And exactly. So that gets harder, but those will continue to improve. At some point, we're going to get to where the abstraction is going to have to move from, today, like before we used to write in assembly code and really low level down to the machine. And then you get higher levels of abstractions and we continue with higher level languages. Well, I think we will just get to yet another higher level language or, because it's coding, there will be many higher level languages because no one will agree on one. But, we'll get to something that will probably, in theory, be closer to, English or a natural language that will, we will not think, there will be the kind of almost new compiler. We won't think of what's below the surface. And, that will kind of move to, more of the sort of technical product person plus the product level of engineer of, really thinking through the problems. Those will be sort of guiding those sort of systems to generate that sort of thing. And, that's kind of, the transition I see over a longer horizon. It's hard to know if that's, does that start? I mean, in anything like when it starts and when it actually affects lots of people is always a huge distance because we're still writing COBOL in mainframes. That's still happening, and the AI has really interesting aspects there because it can fill gaps that we can't do today because no one wants to write anymore. But when it starts, is it 3 years from now? Is it 5? It's hard to predict, but like I think we are on that journey to, we've been on that journey for continuously in development of like moving up the stack and having sort of more black boxes below, so you can build more on top. And this is just
like
another evolutionary layer to abstract the complexities below. I think it becomes even more interesting is like past that abstraction layer, if you can get to systems that are much more real time, where you're not actually even speccing out this, you're just saying what the shapes and data are, and then the users, the way they interact with it, auto renders what is needed based on what they're interacting with. And I think that's more way out there, but like it's really interesting, and it's like in narrow band, it's not even that far out there, but this could be really exciting too. Yeah, because then your interfaces, like what you're trying to get done, are truly meeting you exactly where you are, because it's you're trying to get this one thing, and it's perfectly tailored for what you're trying to do. Yeah, and how you behave, and it's unique to you rather than multiple.
Yeah, I mean, it sounds like an exciting future, honestly. I think, for devs who've been in it for a long time or are just getting into it, I think there's a lot of exciting stuff. There's definitely some risks and downsides, but
there are risks. There's a lot of questions the industry is going to need to grapple with, and there will be tough transitions in that period, just like any big change. So these are things that shouldn't be taken lightly, but it's also super exciting.
Yeah. Hey, well, we're here for it. So awesome. Thanks, Eric, for joining me for our fireside chat. Thanks, everybody. I hope you enjoyed our conversation.
Thanks.
That was a great session, Eric. Love hearing your insights on what's next in developer tooling.
We've been chatting a lot about AI, but how exactly does it impact your team's dynamic? Jeff tackles this question head on in a session all about building adaptive, resilient dev teams.
Hey everyone, I'm Jeff Hollan. Great to have you join this session on building adaptive development teams in the AI-driven world. This is a topic that I'm really passionate about, hoping to share some things here that will help you in learning and navigating and giving you some ideas on maybe what's worked with other organizations if we try to figure out how best can we take advantage and surface the benefits that AI can bring into our organizations. Now, we only have about 20 minutes, so I'll try to keep this pretty focused. Before we get into it, though, let me give a quick introduction of myself. Great to meet you. I'm Jeff. I'm currently Director of Product at Snowflake. If you're not familiar, Snowflake is the data cloud. This is a multi-cloud data platform, everything from doing data querying, analysis, engineering, AI, ML. I personally focus mostly on some of the developer compute capabilities, so running Python, some of the developer tooling. I've worked a lot with developer and developer tooling throughout my career, very passionate about it. I've been at Snowflake for about 2.5 years now. Before that, I was at Microsoft. There, I was running the product team for their serverless compute business for Azure. So serverless Azure Functions, Azure Container Apps, Azure Web Apps. Spent some time with other products as well. Loved my time there. Again, working very closely with developers. I really love, presenting at conferences like this, playing with technology, seeing what some of the latest and greatest stuff that can do, building and working with developers. In fact, if you want to reach out, if you have any questions for me, questions on the presentation, you can find me on Twitter, X, at Jeff Hollan, on LinkedIn, wherever. Happy to chat with anyone. Happy to help. Okay, so let's jump into it. Obviously, this is not news to anyone, but this will kind of lead us in a little bit about what it means to build an adaptive team equipped to be the best suited for running AI applications and AI workloads and taking advantage of AI. And I think the big data point here is really AI is a transformational technology. Yes, it's now been a good, year and a half, 2 years since generative AI has really taken hold of everyone's hearts and minds and imaginations, but we are still very much just in the early phases. And AI is going to disrupt so many different aspects of industries and businesses. How teams are developing, how they're collaborating, the types of people who are involved in those teams, how and the types of solutions we can build, and how our users interact with our systems through natural text and speech and you name it. In so many different aspects, there's a lot of upside here. And the purpose of the next 20 minutes is to share some of the observations that I've had as I've worked with organizations and customers building AI solutions through my role now at Snowflake, of some of the characteristics that will set you best up for success in this AI-driven world. So how can you be a winner in this space and not be on the sideline? If you think back to almost mobile, it was very clear a few years in who was taking mobile first seriously and who would have, like a desktop site that would just render on your phone and not be super optimized. I don't want you to be that one. I want you to be the former one. I want you to be a winner in the AI world. So let's jump into it. So there's 4 main principles that I'd like to recommend in building an adaptive development team. First one is embracing continuous learning, foster a culture of experimentation, balance AI with human insight, and prioritize ethical considerations very early. So let's jump into each of those now. So the first one, embrace continuous learning. This is a topic I'm incredibly passionate about. I mentioned I used to work at Microsoft before Snowflake. I worked there for about a decade. For those who are familiar with Microsoft or Microsoft technology, you might be aware of one of the leaders at Microsoft. His name is Scott Guthrie. He's currently the lead for their cloud and enterprise group and AI group, I think. I remember earlier in my career, I was at a meeting and Scott Guthrie was talking about his career. And someone asked the question, what advice would you give? What's something that you've done in your career that you think is super important? And I remember his answer was always be learning. That's something that he was very passionate about, was I want to always be learning. And that's something I really took to heart. It's something I mentioned I like to hack around. This is something I deeply, deeply believe in, is this need to always be learning. This is especially important when there are paradigm shifts like AI happening. And this is going to be a big one. The World Economic Forum estimates that 44% of core skills are going to need to go through some change and evolution by 2027. So a significant amount of our skill set is going to be evolving just in the next 2 to 3 years. So what are some ways that you can embrace continuous learning individually or with your teams? I think a big one is making sure that you make it known that learning is a priority. I'll give an example. One of the big questions that folks have with AI right now, because it is still so early, is, how should we get started here? Is it too early? Should we wait till we see a little bit more best practices? What if we get something wrong? There's kind of that fear of, what if I go spin up an AI project and it ends up being a flop or not a very, very good fit? I absolutely believe that for any project, especially AI project, you should have a clear indication of what success looks like. You should have a clear indication of what the impact for that project would be. However, sometimes just learning is the outcome that is worth it alone. Understanding what it takes to build that tool. I built a few AI projects, like I mentioned, kind of on my spare time or helping work with customers. Some projects that analyze support cases, some projects that enable me to have chat-like experiences. I built a little AI bot at one point that would help me, give me workout ideas. Like when I go to the gym and I don't know what to do, like a little optimized bot that knew about me. Each one of those projects, I learned so much from what works well with AI, what doesn't work well, where did I have an expectation that was met or unmet. It was incredibly valuable, and I think that's essential for every team to be doing. So encourage and create space for that learning. Make sure people know this is a priority. Make sure that learning is a valuable objective. I'd also like to emphasize, though, oftentimes in different employee surveys, you'll hear employees a little bit discouraged with learning. They're like, hey, my organization is not doing enough for me to be learning. And there's something to that, to be clear. It is absolutely essential that organizations spend time and energy in creating programs and systems for learning. However, I strongly believe that learning is an individual responsibility. That in the same way I can't complain at my organization if I don't have enough time to shower or brush teeth because they're not providing showers or toothbrushes at work. Like, no. Like, obviously, don't work 24/7, but some things are my responsibility. And I deeply believe that learning is one of them. So don't wait for an organizational program to come in and handhold you through learning. Find ways to do it on your own. And again, I'm not saying work is the only important thing, but find that time to learn and make sure you're building an organization where that is encouraged. The other big part here is just learning in a vacuum is not very helpful. When learning is happening, make sure that there are forums, that there's avenues, that there's systems to help share out those learnings. Maybe you highlighted it in something like a team all hands or a team meeting. Maybe there's a team blog post internally or externally that you encourage or incentivize or reward people for participating in. That sharing serves two purposes, really. The first one is, one, other people make learnings as well, even though they might not have actually gone through the experience. But the other one is, it really helps you solidify your own learnings when you have to explain it and share it with others. So those would be my recommendations. I linked here. There's been some great research by folks like MIT on some continuous learning and the impact that it has. This is essential for every team to start learning actively to find out how to best adopt in this AI-driven world. Very related to it is fostering a culture of experimentation. Now, this is, like I mentioned, kind of an extension of learning, but the frame of mind here that I would encourage, especially for teams early in the process, in these initial stages, is make sure you're thinking more like a scientist and less like an investor. And what I mean by that is, a scientist, they have a hypothesis. They then go test their hypothesis. Maybe their hypothesis was correct. Maybe it was wrong. They're not, hopefully, biased by making sure their hypothesis is correct. They just want to know what's the truth. Like, what is the actual truth of this question? And whatever that truth is, maybe it validates my hypothesis. Maybe my hypothesis was wrong, and now I have a new truth that I learned or a new hypothesis to test. That's success. An investor looks at something of like, hey, I'm going to put in some money and I need a return on my investment. And if I don't get the return that I expected, then it was a failed investment. If you approach AI like an investor in those initial stages, you're going to overlook some of the value of those learnings, some of the value of understanding and adaptive. Another failure mode in this, kind of the first bullet point, is something I see a lot of organizations trip up on is, hey, there's a lot of unknowns in this AI-driven world. We don't know how to do testing and explainability in some of the same ways. Maybe some of the tool sets require us that we integrate with systems in ways that we're not used to or familiar with. Should we hold off doing anything until we can do everything? And I would really, really encourage taking some leaps of faith, even acquiring a little bit of technical debt so that you can benefit from that experimentation and that learning. Of course, be responsible. Make sure you're making a plan to circle back to finalize and close out those open questions, but go through, learn those things, share those learnings. Not every experiment is going to be successful. More often than not, when I talk to organizations who are learning how to build AI-driven teams, they'll say something like, hey, we did 10 projects, 5 or 6 of them, we realized this isn't viable. Like, the return on investment isn't there, and that's okay, because we learned that 5 or 6 things aren't ready right now, but we found 4 things that are, which is also an important part that you also need to be sure you're objective. I think the another failure mode we often fall into is, the set of individuals who maybe worked on those 5 or 6 things that didn't turn out to be viable, it's now their baby, right? And they're like, oh, well, we want to keep pushing this forward and keep pushing it forward. Part of approaching it like a scientist means that you're able to say, like, no, this one didn't pan out. Let's go focus in on the areas that did. Let's go optimize and learn and do the next set of investments. And of course, recognition. This, again, hand in glove with the learning aspect. Make sure you're creating space and time and actual ways to recognize people who are experimenting. Make sure that they feel valuable. Make sure that others feel like this is a valuable use of their time. And that even a failed experiment is a valuable one. I think often we get caught up on recognizing successes. Hey, this team shipped something. It resulted in $10 million. Everybody celebrate this team. What about the team who tried something that failed and maybe they sunset it within 2 or 3 months and they had valuable learnings from it? Of course, there are differences between these two things, but recognize those folks too. Because if you don't create those safe spaces for experimentation, people will be very cautious of doing that experimentation. And per all that we've said, you do not want to be too slow in this AI-driven world. You want to be ahead of the curve. Now, there's some practicality that I'd also emphasize as well of building an adaptive team, and that's make sure you're balancing AI with human insight. Okay, so consider how you can build systems and processes that will use AI as a supporting function. In the world of development, I think there is a tremendous opportunity, and we're seeing parts of this already when it comes to code authoring, operations, DevOps, CI/CD, where AI is going to actually help us be much more productive. However, you want to make sure you're building AI into those systems where you still are taking advantage of human insight. Make sure you're regularly checkpointing where is AI working and where is it not? Where maybe is this introducing more problems than it is benefits? Or how can we mitigate against some of the risk when a problem might surface? How do we recognize it? I strongly believe, again, this is my observation and my belief. Maybe I'll be found to be wrong here. The AI will create much more opportunity and create more jobs than it will less. And I say that in part because I have yet to meet with a team who says, oh yeah, we have enough developers, we have enough engineers, we have enough data scientists, we have enough DevOps engineers, like we're set. There's always room for more. And I think AI will help us be much more productive, but keeping space for those human insights, figuring out how your systems can support and evolve around the AI rather than replace it. So some of the tasks that we do, maybe some of the more mundane or repetitive tasks might be augmented by AI more, but you still have the human who's continuing to drive and direct and review those processes. So that's an important consideration to make. And a last one, which could not be understated either, mostly want to make sure that folks think about this early in the process, is how you can prioritize ethical considerations early in the progress. One thing that I found is very beneficial here is make sure that your teams are built on a central mission, a deeper mission. That mission is not make more money or beat the competition. That is not a grounded mission. A mission is generally something that more connects internally. How are we empowering individuals? How are you making others' lives better? How are you making the world a better place? What is your organization's mission? How are you improving the lives of others? And if you can have a mission like that, often you can checkpoint what you are doing and making sure that the means are going towards the right ends, that you're not inadvertently introducing biases into the system or privacy concerns or environmental concerns. You're not trading off on some of those things that are actually creating a net negative in society or a net negative in the world. And it is something that we need to be mindful of. Like many things, like inclusion, like diversity, like equal opportunity, I think this is something that we can't just assume will happen on its own. We need to be conscious of. I am very optimistic by nature. I deeply believe that AI will have far more benefits than it will negatives, but I think we need to keep this in mind. I think teams need to be mindful, checkpoint, have postmortems, think about how bias can be filtered in, how not having observability or explainability can make it difficult to ensure quality. That we need to respect privacy and environmental considerations. So keep that in mind. Just regularly checkpoint, like have it on your list. Hey, every month or every quarter, let's go through and see, are there any ethical considerations to be aware of? Because you don't want to be caught by surprise on this. You don't want to get so many steps into the process only to realize, you know what, we built this great system that's helping us augment our recruiting process, but you know what, it's really biasing our insight, and we actually need to take some corrective actions here. So keep that in mind. It's absolutely a risk. And now, of course, I mentioned I'm optimistic by nature. I am so excited for the opportunity all of us have here in building adaptive teams for AI. I deeply believe through my own experience of building some of these little, widgets or apps, and also seeing organizations who are starting to leverage AI through my job at Snowflake, I think there's such an upside here. And this is one of those moments, these, last year and a half and the next 2.5 years or so, these are things that only happen in a decade or so, right? These are fundamental shifts in technology, internet, mobile, personal computing, whatever that thing is. We are experiencing one of those right now, and we all have the opportunity to be a part of that. So enjoy that. Realize that there's going to be change, and change is often, if not always, uncomfortable. But realize this is great. Like these are the moments that at least I live for, right? Being a part of those. So find ways to bring teams forward, to amplify the positive impact of this technology. Figure out how can we make the most good of this and not be too bogged down by worrying about the negative. And there is negative aspects for sure. Like any of the other paradigms that I just mentioned, there's a good and there's a bad. So let's do what we can collectively as a community to bring forward the good. And that community aspect, I think, is so important. Learn, share, participate. What's working for you? What's not working for you? What do you agree with? What do you disagree with? Let's go through this journey together, and let's figure out how to build these adaptive teams. I think the last note that I'll close on here quickly of what I'm excited about with AI is when we think about adaptive teams, especially adaptive development teams, I'm encouraged to think that the people who will be able to participate actively is going to increase dramatically because of AI. I think about AI tooling. Like I have the ability to write code. I have the ability when I think up something that I want to build, I can usually go and build it. I'm not a great developer, to be clear, but I know the basics. Like I know how to write a simple web app or a simple mobile app or, some simple backend logic. There are many people in the world who don't have that skill set, but have wonderful ideas. They have wonderful contributions. And right now it works out because they find a ways to participate in that process. I think AI is going to open up this world to so many folks. What we look at today is our development teams, our product teams, our DevOps teams. I think a larger set of individuals are going to be able to participate heavily in that because of the benefits that AI can bring. That's going to cause change. Like I said, we're going to have to think about things differently. We're going to figure out where we specialize and where we don't, how we keep humans in the loop. But overall, to me, that's a very exciting future to think of what we can all build together as a community. So that's what I wanted to share. Thank you. Hopefully this was helpful. Hopefully this gave you some ideas, gave you a little bit of courage to go and embrace that learning. Make sure you're experimenting, encouraging your teams to do the same, recognizing folks who do. If you have questions, like I mentioned, you can find me on social. Thank you so much for tuning in, and I hope you have a great rest of the conference.
Thanks, Jeff. Really interesting insights into how dev teams can make the most out of AI-driven tools.
Next up, Ambily will be talking about how GitHub Copilot is transforming the world of DevOps.
Welcome to today's session on how generative AI is reshaping the developer ecosystem. We are at an exciting point in technology where AI is not just assisting, but actively transforming the way developers work, collaborate, and innovate. In this section, we will delve into AI tools like GitHub Copilot and how they change our day-to-day development practices, how these tools streamlining everything from coding till the documentation, testing, and beyond. I'm Ambily, and I'm excited to be your speaker today. I currently work as a cloud solution engineer at GitHub, where I focus on empowering developers through innovative tools and technologies. Especially my focus is GitHub and the AI product associated with the DevOps ecosystem. As a YouTuber, author, and speaker, I'm passionate about helping developers unlock their full potential, especially with GitHub Copilot and a streamlined AI-driven platform. Let us get started. This session will take you on a journey through the transformation of programming, from its origin in binary code to today's AI-driven advancement. We will start looking at how programming evolved over the time, explaining how natural language processing and modern AI is driving the momentum. Then we will delve into GitHub Copilot, a tool that shifts the developer's focus from writing syntax to understanding intent, allowing us to build solutions faster and with great accuracy. Finally, we will move to the future of developer. What areas, roles, skills the developer need to possess for the future AI-driven ecosystem. Let us start with understanding the programming or the transformation of programming from the first generation till the fifth generation. We begin with the first generation, that's a binary code, where we focused more on zeros and ones. Later we move to the second generation, that is assembly code, where we given symbolic instructions almost matching the written statement, but it's all command driven. Later, as part of the third generation, we developed high-level languages. These languages made programming more easy, more manageable. We are able to get the languages like Java and C. Later, as part of fourth generation, we got the task-specific languages, the languages dedicated or specialized for specific tasks, something like database management tasks, Lisp for the AI development or ML development. Finally, we reached to the fifth generation, that is the natural language processing or NLP, where we are staying today. This level allows for human-like interactions with computers, enabling them to understand and respond to human language. Tools like GitHub Copilot leverage NLP to assist developers by interpreting natural language prompts and generating codes or the associated requirements. This essentially bridges the gap between human intent and machine execution. This progression from binary to NLP illustrates how programming languages have evolved from basic low-level commands, that is 0 and 1s, to more context-specific or intent-driven languages like NLP. Let us look a little closer on the day of NLP and AI in programming. With modern AI tools, not only developers, everyone can use NLP and AI to accomplish various tasks. As developers, we can now write code using plain English, bypass all the complex syntax and technical intricacies. This allows them to communicate intent directly to the AI, which then generate necessary code and save time and reduce the errors. AI and NLP automate repetitive tasks. That's the first step be taken in the NLP world. How to reduce the mundane repetitive tasks to help the developers quickly produce boilerplate or the repetitive nature of code. They can also handle now common coding tasks like writing functions, generating tests, debugging, documentation, and number of other areas. This shift from the fourth generation of languages, that is a task-specific languages, to NLP-based languages, allowed the developers to focus more on logic, problem solving, and creative aspect of programming rather than thinking about what's at syntax, technical details, and etc. This is a significant step forward, and it required some kind of skill development, which we discuss in a later stage. So before going to understand what kind of skills required for the future developers, let us dive into GitHub Copilot. GitHub Copilot is a tool that redefines how we approach the coding, shifting the focus from the syntax to the developer's intent. Traditionally, we used to focus more on learning programming languages, syntax, frameworks, etc. But GitHub Copilot is designed to understand the what and why behind the code rather than just the how. With the Copilot, you can write the prompt in a detailed prompted requirements which describe the desired outcome. Then the AI interprets that requirements or the intent behind that requirement and generate the relevant code. This allows developers to focus more on higher level goals and business logic instead of syntax details. So now GitHub Copilot is bridging the gap between human language and the code, enabling everyone to be a developer. Anyone with a good understanding on your requirement, business scenarios, you can code. You can generate a new software. This event empowers developers to think more creative and strategic about their projects. So let us have a simple demo on how the Copilot helping you transform this shift, the focus from syntax to intent, how it empowers the developers to work more efficiently by centering on what they want to achieve rather than how to code. Simple demos start with understanding the requirements with a Copilot. It's not only code generation. Beyond the code generation, Copilot is able to interpret the requirements, give specific business rules and industry standards. Based on industries, you may have different standards defined, like the healthcare have a different standard, government sector have another set of standards. Let we move to a simple code generation based on your intent. Provide the intent, where the developers focus on what needs to be done instead of how to do it. Copilot also plays a major role in generating other supportive codes like the unit test or the performance testing or functional testing. We will look quickly on how to generate unit tests with Copilot and move forward to a more intent-driven design and feature development. As a final step, we do the documentation with the help of Copilot, a detailed documentation or the comments as part of the code, and generate the PR summaries. One of the important steps to merge your work to the main and push to the production. Every project starts with the requirements. Developers need to understand the requirement. Most of the time, the requirements will be captured in the form of a task or a issue, followed by a couple of comments, decisions making, everything. For a developer, it is very important to understand the summary of these entire discussions. Here, Copilot is able to extend the support to generate quickly the summary of maybe 100 or 200 different comments, the proposed requirement, impact of this requirement, and what's the next steps. This helps the developers to understand what exactly the task at hand. Not only the summary, Copilot is there to help you understand further your requirements. You can ask various questions related to your requirements to Copilot, where the Copilot will help you to understand the requirements a little more in details. It may be something related to the project plan, the risk identified, the decisions taken over this particular requirements. Even you can think about requirements like understanding whether a duplicate issue is exists, a related feature is exists. Copilot is there to help you with each of these activities. Once the requirements are clear, you can as a developer move to the coding area. Copilot supports various IDEs, including VS Code. Not only IDEs, Copilot supports the browser-based interface as well. As a developer, either you can use the chat feature for getting the result along with the selection of multiple different models. I'm going ahead with the 01 preview right now. Copilot is not only restricted to this chat feature, it can generate the code based on your prompt as part of the code base itself. Here, based on our requirement, Copilot generated the code. You can review the code and take the code into consideration. Copilot came up with a lab size of 15, and let us see any solution is possible for this particular combination. As you can observe that Copilot defined the solution path with a 15 lab size. Change the lab size to 40 and generate a new lab. Cool. It's able to generate the lab, and based on the same algorithm, either you can go with a depth first or breadth first, which algorithm you select, and go for generation of the solution. Visualizing the generation of the solution. This entire lab escape system is defined using a single prompt, which captured the end-to-end aspect. I have specified the prompt clearly what exactly we are looking at. So as a developer, we need to have this new skill set, how to articulate our requirement clearly to the AI system. Once you define it clearly and you are confident on your selection of the model, you will be able to achieve almost complete solution. Copilot is not only working on this chat interface. As a developer, sometimes we look for support in the ID itself. If I want to add an else portion here, and as you can observe that Copilot is coming up with some kind of suggestions. There are 2 suggestions. I can move between both the suggestions and take it out. It is not mandatory to provide the prompt in the chat. As a developer, if you feel comfortable in continuing development, start typing or give the commented requirements. Copilot is able to generate it. Now we completed the code development. The next step is the unit testing, one of the biggest area of a development cycle. We should ensure that the developed code is meeting the code quality requirement and functional requirement through various test cases. So I'm going back to the GPT-4 model and asking Copilot to generate test cases for one of my method. It's an Angular method using the / commands. You can use either the / commands or you can use prompt for generating the unit test. Here Angular based unit test is generated based on the selected method, the add property, and it's provided different set of data, sample data for testing this particular method. Similarly, if I want to generate the unit test for the entire file altogether, I can specify their test #file, which file I need the property controller. So generate the unit test cases for this particular file, which consists of multiple methods. It's an API class with multiple methods. Copilot came up with set of test cases starting with the hello world API endpoint, get, post and everything. And some places it's used the mocking as well. It's understand that there is a dependency on the DB set. Instead of going directly to the DB set, it's mocked that area with the properties. The appropriate mocking is applied so that the unit test case will be properly validate the functionality implemented as part of this endpoint method. Once we complete the unit testing, obviously we look for the enhance your code quality in terms of readability aspect. Comment my selection. So I have only one method selected. I want to comment only that method. Provide a inline comments which gives a proper readability for my code. The Copilot comments are context aware comments. It takes in consideration of the method and the corresponding classes and provide comments for a block of code. Here it specified the property entity ID for each image URL, save all changes to the database, returns the response. So it's provided a detailed comments. Let us generate the API documentation for #editor. So here I am using another context variable #editor indicating the currently opened file. The documentation is an API documentation which I am expecting. And as you observe, the Copilot came up with a detailed API documentation which discuss about each of the endpoint, the request format and the response. Based on the project and the requirement, you can ask Copilot to document your project, the overall project, for your README file or for a leadership presentation. Now coming to the code generation again, it's not only simple code generation. Copilot is able to understand high-level architecture patterns and also domain specifications. You can specify that you need the code aligned to a specific domain altogether. Here, we are using the Copilot for a microservices development. This time, it's taken the context of the current file, that's a C# file, and defined the microservices pattern using C#. But if I switch to the TS1, and ask Copilot the same question again, this time you can see that the microservices setup will use the Node.js approach. Copilot is context aware and also it's understand the architecture patterns based on your high level descriptions. As a developer, we drill down to the requirements with the help of Copilot and generated the code, generated unit testing and documentation. Now the code is ready for merging with the main code base. Let us see how we can take the help of Copilot as part of your PR. The first concern with the PR is generation of PR summary. You may have done a lot of code changes. It's difficult for us to capture each and every changes as part of the PR. Copilot is extending its help to define and capture all the changes as part of a PR summary. Once you generate the PR, Copilot play multiple roles. You can just add Copilot as one of the reviewers, or you can use Copilot to review the file changes. In the file changes, you can take the help of Copilot to explain the changes which is part of this PR. Let us see how Copilot coming up with the code review recommendations. Recommendations are captured here. The SQL query is constructed using string concatenation that leads to SQL injection. So you need to change that one. If you are fine with the recommended changes in terms of converting this string concatenation with the parameterized queries, you can commit these changes directly into the code base and resolve the conversation. Copilot is not only supporting these 5 different stages of development activities. As a developer, you can leverage the power of GitHub Copilot in various other areas. The developers needs to master the art of translating complex programming tasks into natural language commands. That's the ultimate requirement or skill set required for a future developer. How he can articulate the requirements in a more systematic natural language commands. Embed the NFRs as part of this thing. This required not just technical skills but an understanding of AI's strengths and limitations. Knowing when to use AI when human intervention is essential. Developers also needs to adapt to a prompt-based approach on the outcomes and how to revise the prompt based on AI feedbacks. Moreover, developers should understand the AI's applicability means optimizing workflows in a complex AI ecosystem. The developers also needs to build the ability to understand multiple models and how he can leverage the various models. The future is awaiting. GitHub recently released an NLP-based app development platform called GitHub Spark. Let us have a peek into the future of app development. I'm asking Copilot to develop a small game based on my requirements. All my requirements are captured in natural language where the AI will interpret my requirements based on the intent I have passed. Our app is ready for trial. Let us have a play of these things. Winner is a cat right now. You can revise your apps by providing additional requirement in terms of what exactly you are looking at. Let us see the new players in action. I have cow and elephant is going to play this particular game now. This is how the future of app development. The requirements are passed in terms of natural language and AI is generating the code behind the scene, come up with different iterations as well. Moreover, it supports all kind of models here. We used Cloudy for this particular experiment. GitHub Sparks give an early preview to the future of development. Thank you for being part of today's session. If you have any further questions and would like to connect with me, please reach out to me on LinkedIn at Ambily or through my YouTube channel Tech Drill, available at Ambily. Thank you again for your time and participation today. As we continue to embark the power of AI and automation in development, let us stay curious, keep exploring, and innovate together. Have a great day. Thank you.
Thanks, Ambily, for walking us through GitHub Copilot's versatility.
Staying on the GitHub Copilot train, Frank will demonstrate how it, along with Visual Studio, can help you tackle complex challenges more efficiently.
Bonjour, hi, welcome at this session, Advanced Coding with Visual Studio and GitHub Copilot. And I say Visual Studio because I want to mean the family Visual Studio, because today I will be in VS Code, but it's mostly the same experience. There's a few differences. Instead of asking VS Code, we're asking Visual Studio, but mostly you'll have a great experience if you know how to use it. And this session is about real stuff. How can you get better and more efficient? So without further ado, let's get started. So developer challenges, would it be because we want to impress our manager or coworker that we can do the job, or because we're unfamiliar, we just like drop in a new project and you don't know really the code, or it's just like unclear requirement. Like what? Like I don't really understand what you're saying. Like there's not a lot, like a one-liner. We'll see that in a few seconds. So this fella is here to help us. Definitely GitHub Copilot will enhance developers. I should have an echo for each time I say that. It will really help us become better. But there's a gotcha. We need for that to learn how to use it properly, because GitHub Copilot can definitely help us with tons of different stuff, right? Would it be assistance, writing code, like having the interactivity, helping us being more efficient? And that's great, because for a developer to be productive, we need to write the test, searching for documentation, writing those documentation, correct the syntax and all those things. And we don't like it so much, so using GitHub Copilot, we can spend less time in all those activities and more time in, you guessed it, developing. And that's the focus of today. I really want to show you a quick few tips where you can learn faster and get better in, up to your game and solve the issue, closing those issues on GitHub and impress people. So without further ado, let's get started with the demo. Real life developer experience. You'll see if you have a little bit of experience, it's definitely that. If you don't have developer experience, well, spoiler alert, this is exactly how it looks like. So it most of the time start by an issue. Your manager, the responsible, the project lead, assign you a bug and decide that, like it's super important, this is high priority, you need to fix it. And you look at it, it's okay, search is slow. And this project is eShop, and like it's using an API selling material. So say cool, and then you look, hoping for more detail in the description, and it's okay, trying to search on the website is too slow. It probably doesn't work. That's not really helping, isn't it? Okay, so first reflex is what? Well, it's to check the website. So let's do that. Let's switch, get out of the slides. And this is our eShop, very minimalist, as you can see. And one thing we can do is, well, it was about the search. So I'm guessing I should go into the search area. So if I go here and let's say I search, can I have tent? Is there any tent available? So it's searching, it's loading, it's searching, it's searching. Oh, that's long. Wow, this is very long. My grandma typed faster than that. Oh my God. We found the bug. It's definitely that. It cannot be something else. Oh wow, that was long. So okay, so it found 500 product with a tent. I was a lucky guess, right? Okay, so fine. We now know that that was part of the problem. It's definitely too slow. And looking at the URL here, I can see that it's in the search page URL and like search page, I'm guessing, but I don't know much about this new project. So let's see if I close this. Let's have a look to the code, right? So we look here to the code. Let me move on. Like I will stay here for now, but this is our solution. So we can see that there's three projects. So our solution eShop Lite, let's zoom. Our solution eShop Lite has a project here called model, another one product, another one store. So, okay, so now it's time to leverage GitHub Copilot, right? So we can go here and ask Copilot, let's create this, and we could say, if I can type correctly, endpoints plural of this. And then one thing I can do is see here, one thing that is important to show is, not this. I can use pound or use the button paperclip to attach more context. And that's really useful because Copilot will be very smart when some files are already open, but like sometimes you don't want to open all the files, so you could point it at a specific file. Or maybe you would like to read a JSON document and create a class based on that. So you could say, hey, use and point to that JSON file that is not part of the solution. So you could say, hey, use that file and like, what would be the class that deserialize from this document? And then like you could be using that. And you could also ask using the VS Code, for example, asking, hey, what would be the best extension for like working in VS Code? You can do that too. So here I say, show me the endpoint in this, and I will like use the pound. And now I could search here, and I want the eShop Lite. So eShop Lite solution, voila. And I will say solution. So being specific really helps. Instead of having a generic response here, I have something where it says, hey, the endpoints are specified in a file called product endpoint, and I could click on that and will bring the file here. So I have like, oh, that's cool. I have the file here, and I have here all the endpoints. So API product with an ID, a post, I'm guessing to create a product, and I'm like, I must have like a search. Here it is. We have a search. Ding, ding, ding. We have our winner here. So again, here it is. So using that will definitely help us. Another thing we can do is ask, and like looking at this here right now, you say, well, let's try to make the code a little bit more visible. You can say, well, that's a lot of code. I don't understand what's happening. So you could say, explain me, for example, what's this? Product data context. So you could say, slash, so I have all those slash come in, and I can use explain. That's the one I want to show you. You can ask Copilot to explain new things. So let's give it a try. So for example, here I will remove here, and I will say, let's open a new context here, voila. So now we can say explain, and we want to know more, and then usually Copilot is very verbose, so we can say don't show code. Okay, so now we learn if I expand here, the key concept of the data context is like initializing the database, like creating the property configuration and all those things. So it kind of really helps me to understand what it's about. And so, okay, cool. So what I understand now is that was the database created. I could ask, fun fact, if you want to try it, you could get and say, hey, how many products are added in the initialization? Okay, so now we have it. So let's open a new context here, and let's scroll to find the search. And here we have it. We have the search. So you know what? Let's close this one because I want to show you the chat is nice, but there's another way also that you could communicate with GitHub Copilot, and it's the inline. So here is our search, and there was like an attempt here to monitor how much time. So we could, using the inline command, so it's Control I or Command I if you're on a Mac, and that will should bring, voila, the Copilot. Now I can ask stuff. So I could say optimize, voila. So I'm asking because like a coworker told me we're using entity framework. So I'm saying, okay, cool, let's do that. And now I see that it changed. And here it's like, hey, this is how you could use it. And like I was asking to use like, I didn't really know about it. A smart way will be like to ask Copilot about entity framework and the function light, how it works and things like that. Now I could just accept it. There it is. And if I rerun the project, it should be better, right? So let's give it a try. Okay, so let's go again in the search, and now we could search for, let's say 10, and I click here the button search, and boom, that was way faster. I think we definitely improved that, but that's great. We fixed the problem, but how can we prevent that in the future? That's a great question. Unit tests are often a way to do that, and making sure that other changes doesn't break this. So how we can fix that? So if we look again to the code here, let's stop the project now. If we look into the code, so we were in the product, so I'm guessing that's the API. So let's go into the store and into the pages. There's a search here, and we can see that there was an attempt before about like having, you know, let's make the code bigger and counting like how much time it takes. But that's not great. That's not a very pro way to test an API. So we can ask Copilot about it. So let's again ask Copilot, and we could say, let's do again, be specific will be about this. Let's do it that. Okay, so it's telling us that we could write unit tests using XUnit or other things, but I heard about a file, like a HTTP file. So let's go again and ask, how about using a HTTP file? How can we test the search call with that method? Oh, there it is. So with that, it explains how it works and say, cool, you could do that, and you could just like specify this. Oh, that's interesting. So now we could add this if we had the file. So we need to create a file HTTP. But if I look at the solution here, what it was in the product, obviously, oh, there's so many files open here. Okay, so like look at that. Here there was already one, but it's only testing the product. So one thing I can do is here put my cursor here, and when I hover this code snippet here, I can see that I can insert at cursor. So I could do this, and before let's close this. Thank you, Copilot. So one thing I will notice here is the port. I need to change the port. Sometime Copilot will get it, sometime no, but I have instruction that to replace that. So let's do the same research as before. So let's use 10. And now for the next part, if like me, the first time you try it, you say, hey, like I don't have this, I shouldn't have closed Copilot because it was saying to install a REST client extension. So you could go in the extension, search for that, install it, and then you will have the button. So once you click that, it will make the call and you have it. And this is a proper way to test. So you have exactly how long it took, the response and everything. So that's really helpful. So I hope that helps you to experiment, use those pound, slash, and @ command to really specify and go a little bit more, adding details into your request when you use Copilot, it's really, really useful. So I hope you enjoy. And if you have any question, find me on social. I'm F. Boucher. I'm always happy to help and answer your question. See you next time.
That's a good question. Maybe idea generation. So where like it comes from a lot of aspects. You can tell AI what to do and it will go do it. I think AI can do more in the near future is a little more originality where it can create larger concepts from scratch, not just how to do it, but what to do. And not to mention complete alternatives to what you're doing.
To me, AI is like we have this amazing new capability now, and we're always like jumping right to the end of like, now AI is going to be the developer and do everything, right? And I think of it similarly to how like autonomous cars, we always just jump to like every car is going to drive itself, but AI will slowly integrate in a lot of different places, and there's really like small, awesome things that AI can do that just cuts out a lot of, noise or stress in a developer workflows.
I think as costs come down, algorithms speed up, we're going to make it easier to run multiple systems, and you could have AIs talking to each other. And, we have two halves of our brain that are constantly talking to each other. And they come up with a single answer. And I think you're going to see a lot more of that is like multiple AI agents or modules that work together. This one specializes more in a higher level design. This one specializes more in the nitty gritty, writing a subroutine. I think it's mostly people aren't talking about that because we're not ready yet. But I really think that that's on the horizon. That's what I'm really excited about, is to see more of not just here's a single agent operating in a non-AI world. What happens where we can get multiple agents working together?
Thanks for that informative walkthrough, Frank.
Next, Rizel will share how she used open source AI tools to create a privacy-focused pregnancy app.
Hey everyone, my name is Rizel Scarlett, and today I'm going to be talking to you about prompting AI to build a pregnancy app that I could trust. All right, so let me just give you a little bit of background. For me, in my opinion, I don't think we talk about pregnancy in the workplace enough. It's kind of a taboo topic. It's also a very sensitive subject for many pregnant women, of course, or birthing people. But I also think because of the lack of discussion, this also leads to poor maternity leave policies, because a lot of our industries like tech are so male dominated. And then that leads to overworked expecting moms. And also, I think we've ended up developing a lot of privacy invasive pregnancy apps. Try saying that like 3 times. But basically, I think a lot of the tech industry will be like, oh, let's get into this area in the 2020s or 2015s or whatever. Like, let's get into this area where it seems underserved. Let's make these apps for feminine personal health data. And then they figure out, oh, like, we don't care that much, or at least as a user, you figure out, whoa, they don't really care that much for my privacy. This is nice to track, but it's also sharing my data with a ton of different platforms. Before I go any further, my name is Rizel Scarlett. I'm a staff developer advocate at Block. I'm very passionate about open source and AI, and I'm passionate about data privacy as well, which almost seems opposite of each other. And one of the reasons I'm interested in this particular topic today is I'm 35 weeks pregnant. And with that, I will tell you the agenda as well. So we're going to talk about lack of data privacy online, something I found called decentralized web nodes, AI agents, tips and tricks for using AI agents. We'll do a bit of a demo, and I'll show you all some resources. So it's going to be lots of fun. So I'm already used to, and you all are probably as well, apps that just collect massive amounts of personal data about you. And really, we just kind of accept it for what it is. And oftentimes we accept it for what it is because that's just how the internet has been. But that shouldn't be how it always is, right? I started thinking this is really weird when I downloaded an app when I decided, I think I want to start a family. And TikTok, Instagram Reels, Facebook, Target, everyone, YouTube, every commercial had to do with becoming a mom. And I'm like, dang, how do you guys already know? I just downloaded the app and nothing else has occurred besides downloading the app. And I figured this can be also annoying and very invasive if someone has experienced a miscarriage and now they're being constantly reminded by different applications about motherhood. So the question that I pose to you all is, who should really own your data? And from my perspective, it should be you. You should own your own data. So one thing I looked into is called DWNs, or decentralized web nodes. They're open source. They are basically a personal data storage mechanism. So you can think of it like a Dropbox, but it's encrypted, and you as the user have ownership over it, and you can control who has access to different types of data in it. And how that's made possible is with something called protocols. These are JavaScript objects or JSON objects, where here you can see you can define who can do certain things, who can like read, who can write, who can query your data, and all of that. So in this particular situation, they're saying for this web app, anyone can create a chat, but only the author and the recipient can read that chat. And you can, if you've made a pregnancy app or anything like that, you can say, oh, I only want the provider to be able to read this, or I only want my partner or my parents or just myself to be able to have access to this data. So I thought of like a wild, kooky idea. Can I use AI to help me build this app that uses decentralized web nodes? Partially, I'm a little lazy, so let's see what we could do. And I decided to look into different types of AI tools. I've used GitHub Copilot heavily. I wanted to try something new, so I'm trying out Goose today. And Goose is a developer agent local to your machine. It's available in your terminal, also available in your IDEs like Visual Studio Code or IntelliJ. And like I said, it's open source and it ends up having full context of your project. Now, I do want to emphasize it's not an LLM, and we're used to LLMs, which are known as large language models. They're trained on large amounts of data and use prediction algorithms to generate, summarize, translate, and analyze content. So that content could be anything: images, video, code, or just text. And we probably most used to using like GPTs from OpenAI, like GPT-3, GPT-4, Sonnet, Gemini. Maybe you don't even realize you're using it because sometimes it's abstracted away with a user interface such as ChatGPT or Claude or GitHub Copilot or Midjourney or Google or DALL-E or all these different things. But we're interacting with LLMs behind the scenes. Instead, as I mentioned, Goose is an agent. And now, the AI world, we're having a tough time with definitions right now. So people are struggling with figuring out what's exactly is an agent. But the way I've defined it, at least in the context of Goose, is that it's software that can execute operations without human intervention or with little human intervention. And basically, their agents are given a goal. They decide on what actions need to be made to reach that goal, and they take that action to reach the goal. So in my personal opinion, I think Goose is more of a semi-autonomous agent because it can do everything for you, but it does take some time to pause and check in if you're okay with some of the commands. And I like that because I know that AI hallucinates. Like, I recognize that. I know that it makes mistakes. So I feel safer knowing that I'm maintaining some level of control. So I also wanted to know, just for my personal gain, is like, agents, the way it sounds, it's just automation, but what's the difference? So agents are more given goals to achieve, and then they learn, adapt, and make decisions to achieve those goals. Whereas with automation, it's given a situation, responds to the predetermined action if the situation matches one of its recipes. The way that Goose works in particular is you bring your own LLM, whatever you prefer to use. Do you like OpenAI's GPTs, or do you like to use Sonnet by Claude or whatever it is? You bring the one that you think is good for your situation and the one that you like to use. Then you prompt Goose and you say something like, hey, I want to create some unit tests. And Goose, it goes to the LLM and it's like, yo, LLM, yo, GPT-4o. Rizel wants to create some unit tests. How do I do that? I need you to make a plan for me. And then the LLM's like, okay, first, you're going to install React testing library. Then you're going to look at this first method and you're going to write a unit test for this and that and so on and so forth. Goose comes back to you, it communicates the plan to you, and then it executes the plan through shell commands. Now, we know sometimes shell commands fail, right? Maybe sometimes it didn't type in the right thing or your environment's weird or whatever. So we have some different options, or Goose has different options for what it does when a command fails. It might ask the LLM for an updated plan. It might be like, yo, when I install React testing library, it didn't work. And then it might be like, the LLM might be like, oh, I forgot to specifically tell you which version to install. Sometimes a command might be running too long and it'll stop and tell you, hey, can you tell me what command I need to run, or can you run the command yourself? It might be a little bit faster. Or sometimes the command might need elevated permissions, like your password, and it might be like, yo, it asks for your password. I don't know it. Can you run it on your end and then tell me when you're done? So just letting you know, this demo, the demos I'll be doing will not be perfect because AI is non-deterministic, meaning it's unpredictable, likely to have a different result each time. So no matter how much I practiced before, it might show me something crazy. So we're going to switch over to that in a quick second and start the demo. Okay, so I switched back over to my terminal because this is where I'm going to interact with Goose. And I made a directory and everything. So what I'm going to go ahead and do is, instead of necessarily, so to start a session, I'm going to say Goose session start. And instead of me deciding to create a pregnancy web app, we're going to do something smaller first, or like more relatable first, then we're going to do the pregnancy web app just to see how Goose acts, right? So it started up a session for me, and I'm going to say, let's create a collaborative real-time drawing web app using Next.js. So right now, when it's responding, it's going chatting with that LLM, coming up with a plan for me, and it's going to be able to print that plan out and show and communicate that with me. So we'll see. It's taking a bit, probably because I have a whole bunch of stuff running. Oh, perfect. Oh my God. So it came up with a plan. It's like, it's going to do some basic setup. It's going to set up Canvas. It's going to implement a WebSocket in the back end. And then it starts creating the project with these files and all of that for me, which is super exciting. And it's like, okay, just go ahead and run the project for me. Oh my God, perfect, right? For the sake of time, I actually just had my own on the side running, or I already used Goose to do this. This is kind of like, you know, you watch a cooking show and they're like, we made some cupcakes, but we already made some cupcakes. So I did use Goose to create this beforehand, just for the sake of time, since this is supposed to be a 15 to 20 minute talk. And here we have a collaborative drawing app. It's nothing too crazy, simple. We can always go back and say, hey, add color, add buttons for toggling erasers and stuff like that. But we have something that we see works. All right, so next thing I want to show y'all is the actual creation of the pregnancy web app. But I want to do something a little bit more, like it's a little bit different here. And what I'm going to do is, I recognize that decentralized web nodes, they're not like this common technology. They're new. Not a lot of people are using them yet. And so therefore, the LLM and Goose may not have information about decentralized web nodes like that. So what I did instead is I created what is called a Goose hints file. So I'm going to go ahead and recreate that with you guys. And let's see. We're going to do touch goose hints. And I'm going to open this up in Vim. All right. So in my goose hints file, you can give context to your to Goose so it can know how to operate on things. What I did is I went to the documentation for DWNs and I copied and pasted all the relevant parts. So I'm going to go ahead and do that. And let's exit this drawing web app. I'm going to go ahead and copy and paste this so it knows what to do and when to do it. All right, cool. So now we've inserted it. Oop. And I'm going to do right click. Okay, awesome. So we have our Goose hints file giving Goose a bit of context, but we also want to, or at least I want to, make a plan. So we saw Goose make its own plan, but you can also make your own plan for Goose if you wanted to. And I think of this as I know what to do, but I'm just lazy to manually do it, and I want Goose to do this for me. So I'm going to create another file called a plan.yaml. And alrighty, and we're going to open it up. We're going to say touch plan.yaml, and I already did that. Let me see if I made two. I'm going to do VI. I'm going to open it up and say VI plan.yaml. All right. Now in my plan, I made this ahead of time just for the sake of time. We have a kickoff message telling it what we're going to do. We're going to create a Next.js web app that acts as a pregnancy due date calculator. And I gave it tasks. I'm like, first, create a directory, install this project or dependency, create a UI where users can input the first day of their last cycle, all of that stuff. And then we're going to say, right, quit. Alrighty, now we can start a Goose session, a SQ Goose session. We can say SQ Goose session start dash plan, and then we can say plan.yaml. So we're saying started with this particular plan. And it's supposed to, let's see what I did wrong. Let's put plan.yaml with an A because that's how I spelled the end of the extension. So now it's going to go ahead and follow what I told it to do, right? It's making that directory. It's CDing into the directory, and it is going to install all the things I told it to install, like Next and React and Web5 API for the DWN and all of that. Now, for the sake of time, again, like I said, these run pretty long. I've already done this again, and we see the code that it wrote for it. I've already done this on the side just to make things a little bit faster. It says run npm run dev. I'm already doing that. So we can see what it made. I'm going to bring it over here. It's pretty plain. It's pretty plain. But let's say if your last cycle, the first day of your last cycle was, I don't know, let's pick a random date, April 4, 2024. When you calculate the date, that would say that you're 30 weeks pregnant. Your due date will be Wednesday, January 8, 2025. But the thing we care about is, okay, it's been written to our decentralized web node. How do we know that for sure? I told it to print out if it worked, or to print out the data that it printed to the decentralized web node, and it did. So we have a record here, and this is something I would expect. What my experience with decentralized web nodes is, where it has all the stuff in here, all the encoded data and the record ID. So it was successful, which is really exciting. And actually, I have some time to show you all the web app that I actually had made. So I'm going to cancel all of this. Exit. So that was just a demo one, but I made a more flourishing one. So localhost 3002, a little bit more detailed, and we have time to show this. I'm so glad that we do. So this web app, I mean, it's not the cutest, but I thought it was cool that I made this with AI. I took the time to be a little bit more detailed. And so I'm like, all right, if I get started, click here to log in, and then I put in like what would be my username, and I want to be I'm signing in as self, not provider, not partner. Set my username, and then here is where I can like track my cycle if I wanted to. So I could say, oh, Monday, October 28th, and then maybe the end date was Wednesday the 30th, and then I could put the flow types, maybe started heavy, medium, light, or something like that. It shows the colors for it, or not the colors, but but the indicators for it. And we know it was saved in my personal decentralized web node because it gets printed out here saying that it was added successfully, and we can see that same object that I expect to see from a decentralized web node. So that was like something I did on the side with AI. It would take way too long for me to show you, or with Goose in particular. And for the designs, I actually used vo.dev. So I'll show you all that. vo.dev. This is owned by Rizel, and you can kind of think of like, oh, how would I like prototype or design like a little web app? This is pretty nice and fun to use. And I want to go back and just show you all, if you wanted to get into Goose or try out AI agents a little bit, I would encourage you to go to github.com/block/goose to check out the repo and install it. And then we have documentation at blog.github.io/goose. Thank you so much, and I hope this was an interesting talk for you. Bye.
Really cool to see what you've been up to, Rizel.
Most people are familiar with GitKraken Desktop as a GUI for Git, but did you know there's a CLI application as well? Luís will share how you can enhance your workflows with GitKraken CLI.
Hello, my name is Luís Sivillo, and I'm excited today to be talking to you at GitKon about GitKraken and the CLI. Command and conquer Git, instant productivity with the GitKraken CLI. As previously mentioned, my name is Luís Sivillo. I'm a software engineer and cloud architect at GitKraken. I've been working in the software industry for 20 years, or a little over 20 years, and I've been doing so mostly in the SaaS space. I'm very passionate about distributed systems, event-driven architectures, and DevEx, developer experience. So why a CLI? We believe that we can simplify complex Git workflows for developers and enforce best practices and standardization for managers and teams. So how will we do this? We believe by focusing on multi-repo actions, a single command for all things Git, and standardization is how we're going to do it. So multi-repo actions. We're going to leverage GitKraken workspaces to quickly perform bulk actions across multiple repositories. Workspaces is not something new to GitKraken. They've been around for a while. And now we're going to be going all in on bulk actions across those repositories to boost productivity for developers and improve their quality of life by removing mundane tasks from their day-to-day workflows. So let's take a look at the problem. Let's say we have a React front end in a repository. We have a GraphQL API that serves that repository, the front end. And then we have another series of repositories that comprise the REST API that the GraphQL API layer consumes. And if we want to add a new resource to the API, we need to go into that repository. We need to check out a branch and name it. We need to do a bunch of work, and we need to push it up. And then after we push it up, we want to create a pull request in the issue provider. Then we have to go to the GraphQL repository and do the same thing. We have to do all the same work again. Then when we want to consume the GraphQL API from the front end so we can render interactive UIs for our end users to interact with this new resource, we got to do the same thing over again. CD into the repository, check out the branch, name it, do the work, commit it, push it, create the PR. A lot of work. And the more and more repositories you have, the more and more this becomes a problem. Think about a shared library update that is made, and then you have to go and update all the dependent repositories. That's a lot of work and a lot of mundane work just to update one repository. One repository's dependencies, excuse me. So the solution, now, if you were to take all of those repositories in the previous example and put them in a single workspace, here we're calling it alpha, you could then do a single command to create a pull request across all of those repositories. So let's take a look at that example. A single command, gkpr create, is going to look at all of the repositories within your workspace, see if there are changes that need to be pushed up, and if so, it will push them up to the remote, and then it will go ahead and all the ones that had changes, it will create pull requests in your Git provider that you have configured in the CLI. So now we just see one command that can execute once across all of those repositories. And at the end of the command, you're going to get a nice URL that will bring you to gitkraken.dev, our web-based surface that you can go in and see all the PRs associated with that one issue, and you'll have the ability to navigate to them from there. And then within the PRs themselves, we're going to have links to the associated PRs that all comprise that single unit of work. Number two, one command, all things Git. Whether you're working with your Git provider, your native Git binary, or you're interacting with the GitKraken ecosystem, we want to have a single command to do all of those things, a single CLI interface to do all of those things. So here in this example, we have linked to the GitKraken CLI, our Jira issue provider and our GitHub issue provider. So with a single command, gk issue start login, you're going to go ahead and you're going to see a type ahead pop-up window here that has all the issues across the providers that the issue providers that you have linked. And then you can tab select over to the issue that you want to work on, hit enter. And if you do this in the context of your workspace, it's going to go ahead and create a branch with the same name across all of the repositories in that workspace. And obviously, by default, it will do all repositories, but through command line arguments and flags, you'll be able to exclude or only include certain repos that you want. Use cases. A big use case that really speeds things up for new developers joining a team or a new hire joining a company is onboarding. If all your repositories that a team works on are grouped within a single workspace, you can issue a single command, gkws alpha clone, that in one command will get all of the repositories cloned to that individual's computer. And the alternative is going into your Git provider for every single repository that the team has, finding the clone URL, copying it, going to your computer, CDing into the directory where you want to put the repository, running the command, and doing that over and over and over again for each repository versus gkws alpha clone. You previously saw how gkpr create can really speed things up for pull requests that span multiple repositories. You'll have the ability to see repository health, CI/CD status, and many, many more. But the cool thing, I really love the CI/CD status feature, is because you can issue a single command, gkinfo status, and it will list out all of the commits in all of your repositories that are currently deployed to the environments that you have configured in your CI/CD environment. So I can't stress enough how this is a must-have for projects spanning multiple repositories. And last but certainly not least is standardization and best practices. We want to meet developers where they are, whether it's the GitKraken CLI, the GitKraken desktop, the IDE. We want unified best practices across all of those surfaces. So when you're creating pull requests, having standard names, branch names across all of your different services that you work on. Managers will see that standardization when they're looking at issues in the Launchpad, for example. Additionally, pull request templates, things like that. We are going to obviously focus on AI automations and things like that to help boost your productivity. So a lot is going to be happening around the standardization and best practices as well. So again, in summary, the GitKraken CLI dramatically improves developer experience and productivity. And we're doing this by multi-repo actions within a workspace, a single command for all things Git, and standardization. I want to thank you all for taking the time to listen to me. And I really hope that you stay in touch with GitKraken and keep in the loop about what's going on with the CLI. Thank you.
Thanks, Luís. Workspaces are a really handy way for managing multiple repos.
Getting interrupted when you're in a flow state can really slow you down. Bill will cover a better way to keep stakeholders informed of your progress. That way, you can stay focused.
Much has been written about developer experience, the strategies to cultivate it, the requirements to achieve it. But speaking as a developer myself, I'm confident that once you boil down all the articles and advice into an implementation strategy, maximizing developer experience really simplifies down to one thing, which is reducing bullshit tasks to create more deep work time. Now, in this video, I want to set our sights on a more subtle but insidious time sink, which is the accounting for what's getting done is sort of the quintessential I don't spend much time on that task that people really do spend quite a bit of time on once you add up all the various contexts where it is important to know things like, number one, annual reviews. You're usually spending 1 to 3 hours of preparation, a good chunk of which is deriving what the biggest projects from the last year were. Another one, weekly or monthly progress updates, sometimes with the team, sometimes with the manager, sometimes both. For these meetings, you're not getting anything done for the hour or two before the meeting because that's about how long it takes to produce a curated list of the things that you've worked on since the previous meeting. And the third context is the customer change list. Every product has one of these, and while the developers themselves are usually not leading the effort, they invariably get some amount of time and distraction dedicated to helping the product people round up everything that is deployed since the last product update. It's some of the most tedious, willpower-sucking type of task for every minute that it is underway, because ultimately what you're doing is just rediscovering what you already did. Developer experience would be much better if we didn't have to spend time on this. So that's why I think it's significant that as of this month, our company GitClear is set up to allow developers to automatically generate visual, interactive change logs permanently free for up to a few repos. So what does automatically generating your own personal changelog look like in practice? Well, it's pretty simple. It looks like remembering to take a screenshot and paste it into a web page every few days. As you might guess, there is a lot that AI can contribute to the process of automating changelog generation. Most importantly, when you upload a picture, AI can describe the contents of that picture and reason about which candidates in a list of changes are most likely being depicted by the picture or video that was uploaded. AI is also more than capable of summarizing a group of commits, especially if that group is associated with a Jira or a pull request, which gives more signal about what the commits are actually implementing. The hardest part of this auto changelog generation is deciding which commits should be combined together. By my estimation, I've been working on this problem for the better part of 6 years now to build a set of heuristics that can decide when commits are related, like whether lines from a later commit revise lines from an earlier commit, or whether the commits both involve files changed in the same directory. These heuristics combine developer progress into groups of work that are usually about 3 to 5 days in size, since that is about how often the average developer generates enough progress to be screenshotted and described as a meaningful unit of change. And the benefit of a commit group is that it really doesn't matter what size your commits are. They're going to get combined into one unit regardless of how they were individually bundled at the time. So it really leaves it up to the developer what strategy they want to use to delineate what constitutes a single commit. assuming the developer pastes a screenshot of their work every once in a while, there are at least 3 different sources of truth that can be combined programmatically to describe what change was implemented. You have the description that AI extrapolates from the uploaded picture, the commit messages that form the work that's being shown, and usually you have the title of a Jira or pull request, if not both, when those are referenced by the commit or the branch. Now, honestly, since automated change logs, which we're calling Snap change logs, just launched this month, they're still too new for me to say exactly what percentage of them are going to be able to be auto-generated from combining AI data sources, but I would not be surprised if it was 75% or more, since AI is already pretty good at generating one-line summaries of commit groups. The sum of all this data signal put together means that developers should finally be able to shake free from what I would call one of our most tedious intermittent tasks. Take the time that is saved not reviewing commit histories and apply that to deep work programming instead, and that seems like a reliable recipe for improved developer experience. So I hope you will come give it a try and help define what the future of this feature could be. Thanks for watching.
Thanks for those strategies to keep teams on track, though.
Developers often deal with information overload, but what if you had a personal assistant to help you through it? Kyle from Superna shows how training an LLM on your first day can keep you organized and productive.
Hey everyone, welcome to GitKon 2024. My name's Kyle Fransham. I'm Senior Vice President of Research and Development at Superna, and I'm really thrilled to be here today to talk with you all about a topic that's near and dear to my heart. That's AI and developer experience, and specifically how large language models can help with that. Now, this is no surprise. We all know GitHub Copilot, we know ChatGPT, we know about the impact of those tools on developers' day-to-day work. However, AI has become more commoditized. Now the models are getting smaller. It's possible to run them on the developer laptop itself. So I'm going to tell you about why I think that's important, why all developers should be doing this, and then give you a really quick example on just how easy it is to get going to do that. To talk about why that's important, I'd like to tell you a story about my very first day at my very first job. This is a true story. So I went to a meeting with my boss and my boss's boss, the director of the department, and a couple of senior engineers in a boardroom. And the director says something like, "We had good results on the ABC last night because the DEF didn't kick in," or, something like that. One of the senior engineers pipes up from the corner, "At least it wasn't the XYZ," and the whole room started laughing, except for me, kind of wide-eyed, wondering what's going on. I could have leaned to my boss at that time and said "Hey, what's the ABC and what's the XYZ and what's the DEF?" But you don't interrupt a stand-up comedian when they're giving their act. It just really wasn't the time for me to ask those questions. Eventually in my career, I learned what those meant, what the ABC was and the DEF, and maybe even why the XYZ was funny. Later on, as an engineering leader, I hired a new developer straight out of school, bright-eyed, super intelligent, just ready to take on the world. I was working with him one day, and I don't remember what it was about, but he showed me this document. He'd compiled a 40-page Google Doc where he put all of his thoughts, his learnings, his little tips and tricks. His name wasn't Fred, but let's just pretend it was. And he called it Fred's Master Document of Knowledge. In that moment, I learned a couple things. The first was that as a leader, I had people working for me who were experiencing that same level of discomfort and unknowingness on their first day as I had experienced on my first day, all the way back in my first job. And the second, more important learning was that even if all of the organization and documentation exists to properly teach somebody about your organization, your company, their job, the tools they need, that documentation existing is not enough. The hard part really is knowing where to look. And I've experienced this throughout the years, and I'll bet that many of you have similar challenges in your organizations. Information exists in so many places, Confluence, Google Docs, Slack histories, Git commits, Jira, and the people who are successful are the ones who know where to look. And I'll make another bet is that many of the people who seem to know where to look probably have some variant of their own master document of knowledge where they keep an index of things that are important to them. 5 years ago, this was a great strategy. But as our tooling changes, it's time to level up. LLMs now can be run on the laptop. We can index our own master documents of knowledge and have this available to you in your own development environment quite easily. You can make the argument that organizations are starting to run their own LLMs to index all of these things, and that's true, right? A central LLM is good for an organization to do, and it can have a pipeline to build in things like Jira, things like Confluence and Google Docs, all into a central location or repository for you. But that's not enough. Everyone has their own private thoughts, meeting notes, locations, tips and tricks. And as our master document of knowledge grows, it becomes harder and harder to parse out what's there. So put that into an LLM, index it, and be able to ask the questions in your environment when you're working. Let's get into how to do that. All right, so these instructions are going to be for Ollama. There's other ways of doing this, and this is a space that's changing very, very quickly. So what's here currently now may be different in a few months or a few years if you're coming back to this talk. But overall, the premise and the outline should be about the same. So on Ollama, you can go to this site. It's a large language model that's produced by Meta, owners of Facebook. And they have different models that are available. Some are larger, some are smaller. Really, to get started, I'm using Windows Subsystem for Linux, WSL on Windows. One of the easiest ways I've found. There's other ways, but if I go to download, I go to Linux here, it really gives me just a single curl command. I'm going to take this and paste it into WSL and hit enter. Give my password. And really, that's it. I'm going to pause here and come back when this is downloading. We'll see how it looks when the download is complete. Okay, so at this point, Ollama has been downloaded. It's running locally. You can check that it's started, with the Ollama ps command. Nothing running. Now we have to go and actually download a model. So this is the framework to run it, but we need a model to run locally. Good place to go to look for that is we can actually go to the GitHub of Ollama. And if I scroll down here, there's a listing of the different models. But what's important is this little note. So you should have 8 gigs of RAM to run the 7B models, 16 gigs of RAM to run the 13 billion models, and 32 gigs of RAM to run the 33 billion models. That's the number of parameters. For me, actually, I like to really start small. So Llama 3.2 is a newer one. It has only 1 billion parameters, but it's pretty good. So I'm going to start there. And if you see, there's this Ollama run Llama 3.2 command here, we can just take this and straight up run it. So copy that, paste it into my terminal, and it's going to give me a local LLM that's running on my own laptop. And we can query it, what is the 14th digit of pi? I'm not too sure, but interesting. Look at that. So, it's pretty chatty as a response, and it gave me the first 50 digits, but it couldn't tell me what the 14th digit was. So that's kind of an example, right? I bet you if you asked ChatGPT what the 14th digit of pi is, it would give you an answer. And then just to point out that this also works in the VS Code terminal, so I can, Ollama from in here. And if I wanted some contextual information on, programming or whatever, I can say write me a Python snippet to read a file from a file system and print it to the terminal. Right? And it doesn't take too long. Gives you the code, and you can, use and adapt it from there. Again, right, this is nothing that Copilot can't do when it's installed in your local system, but it's nice to have it running here. The real power, though, as you can see in the background, is being able to train this LLM on your own documentation. Okay, so I have a little bit of code visible here. Actually, I'm going to start with the glossary. There's this knowledge folder, and I've called my repository mdoc, master document of knowledge. So I've created just a little markdown file of stuff that, I think I need to know. This isn't my real one, but just for, for demonstration purposes. A couple of acronyms, SCA, ECA, a few URLs, right? My development server is running on a server with this IP address. And then some procedures, if I want to know how to submit a pull request, for example, well, it's documented here in Confluence. And then put in some private stuff, right? My Bitbucket password and my AWS organization. We'll come back to that. Not a good idea, but I'll show you what happens there. So to train this on this file, it's really just like 15 lines of code. We load the knowledge directory into a directory loader, split it all up, and then create this vector store from that document and get saved in this ChromaDB folder as your persist directory. So I'm going to train it. It takes like 1 or 2 minutes to train, really just Python train.py, and then we'll come back once this is done training. Okay, so really our training only took about 45 seconds, pretty quick. And so now that we've created this vector store, let's look at how to read it. So the point here isn't about the code, right? The point here is that this is about 45 lines of code that really anybody should be able to write on their first day. You can even ask your local LLM how to write this. It's just a little read input loop that takes the vector store and queries it and then passes it to the LLM to get information that's contextual to you. So I have it in this LLM file. We can run it, Python llm.py, and it's going to start up and then just give me a question prompt, right? So now that I have a prompt, I can query things related to me. So this still works to query extra information, but I could say, where is my development server IP, for example, right? And then it's going to go out, crunch that, give me some information contextually local to my environment. So here it tells me my development IP is on 192.168.1.141. And just as a reminder, that's what we had in the glossary, it was telling me that. I can ask it some other stuff. So, where is the procedure to submit a pull request? Pretend it's my first day. REQ. Pretend it's my first day and that I want to, I forget, right? I have to go look up the documentation somewhere. This could go out and also read that documentation and give me answers, but really it's telling me, first of all, it doesn't know where to go, but actually it really does. To do so gives me this link. And actually, if I wanted to, I could just click this and it would bring it up, in an external page for me to follow. That's quite handy. I also put some passwords in here. This is bad practice. Sometimes it'll block it, but I think in this case, if I say, what is my Bitbucket password, it probably gives me the information back. So just as a word of caution, right? This is not a place to store private credentials or anything. So it does block it, right? It says it doesn't know and it won't be able to access it. So there is that kind of level of intelligence that gets put over there to help, protect people from themselves. So wrapping up, I hope I've convinced you that building your own LLM is something that's become so accessible to everyone that everyone should be doing it. As a message to developers, build your own mentors, level up your tooling, and take learnings into your own hands as much as possible. And as a message to engineering leaders out there, first of all, don't replace living, breathing mentors with an AI, but do encourage this type of experimentation and self-improvement amongst your teams. The whole organization will be better for it. Again, my name's Kyle Fransham. You can find me on LinkedIn. I'd love to connect with any of you out there about this or any other topics that come to mind. And finally, I'd like to wish you all a really wonderful time at GitKon. Thanks for hanging out with me today. Bye.
Information sprawl can quickly get overwhelming, so thanks for the walkthrough on how to make things more manageable, Kyle.
Git worktrees are powerful, but often underused due to the complexity of managing them in the terminal. Justin will share how GitKraken's DevEx platform makes that process more intuitive.
Hi everyone, my name is Justin Roberts. I'm a Senior Product Director here at GitKraken, and today I wanted to take a little bit of time to talk to you about Worktrees. You may not have heard of them, you may have used them before, but they're a really powerful tool in your Git toolkit that can help you work on multiple things at once without the kind of cumbersome branch switching that you might be used to today. So I'm going to explain to you what Worktrees are, give you a couple of examples, and see how you can use them both in the terminal and in some of our products here at GitKraken. So let's get started. So we're all familiar with branches. They help us explore new ideas. They help us work on bug fixes. They help us manage different versions of our code. But sometimes switching between branches is really cumbersome. It's a very single-threaded process. If you want to switch from one branch and you have some working changes on it to another one, you typically have to do some work to stash those changes or commit them before you're ready so that you can move on to something else. So what is another way we can do that? We can use Worktrees. First, let's take a look at what the single-threaded development process looks like with branches, and then we'll see how it can be improved with Worktrees. So typically, let's say you're on a branch, you're on main here, and you have some working directory changes. You're not ready to commit those, but you need to switch over to this feature branch because you have something else that you need to do over there. So in the typical workflow, you would just switch branches, right? You would check out the feature branch and you would stash those changes on main so that you could do that. So now you're on feature, you're making some more working directory changes, and let's say that a critical bug is found in production that you need to fix. Well, you need to create a new branch for that, but you're not quite ready to commit these changes on feature yet. So you've got to stash those. You stash those changes, and now you've kind of got these three different branches, all with varying levels of working directory changes that are stashed, that you have to know how to go back to, that you have to either pop or apply to get those changes back into the state so that you can keep working on them. It's a little bit cumbersome. It's very single-threaded, moving from one branch to another. It's a lot of stashing. That's pretty much what it comes down to, is you have to stash a lot to do this workflow, and you can even get yourself into some situations where maybe you have merge conflicts that you have to resolve if you're not quite paying attention. So the better way to do this, in my opinion, is to try using Worktrees. So the way that Worktrees work is they're essentially another directory within your repository. So in this same example, if I was on that main branch and I had some working directory changes, those are on the kind of main working tree. But if I needed to switch off to the feature branch, I could essentially create a new work tree that lets me switch over to that branch, have its own working directory so I can make changes on feature that are completely separate from the changes that I had on main. And if that critical error comes up again and I need a hotfix, I can open up another work tree with those changes. And it's very easy to switch back and forth between work trees so that you can work on changes in one, work on changes in another without having to commit them, without having to stash them, and really without losing those changes, because the last thing you want to do is switch branches and destroy the work that you had in an old one. And that is the benefit of using Worktrees. So let's see how that works in real life. I'm going to switch over to my terminal here. And you can see that I am in the Git Lens repository. And if I do a git status, you can see that I do have some changes in this branch that I'm on main. But I have a new idea. There's something else that I want to work on, and I want to create a new branch to work on those. Now, I could stash these changes or I could commit them, but I'm not really ready to do that. I just had this wild idea and I want to work on something else. So what you can do is you can do git worktree add, and I'm going to call this new idea. And so what that's going to do is it's going to create a new directory within the same repository, that same GitLens repository that's called new idea. It's also creating a branch called new idea. Now you can see that I'm still inside my GitLens repository. And if we do git status again, you can see that those changes are still there. But I want to switch to that work tree. Now that work tree, because it's just a directory, I can cd into that. And now I am in new idea. And if I do a git status, you can see there's nothing there. So I have created a new branch on a separate working directory where I can do some work. I can explore this new idea. I can do whatever I want without getting in the way of the changes that I had on main. Now, working in the terminal, it's a little hard to follow this sometimes. It can be a little tricky to visualize where you're at. So I'm going to switch over into GitKraken desktop just to kind of visualize what's going on here. So you'll see over in the Worktrees section, I have that main work tree that I was on with those changes, and I have new idea here. Now in GitKraken, I'm going to switch to the new idea work tree. And now you can see that I have a branch. It's pointed at the same place as main, but there are no working directory changes. I'm got a clean slate here. If I go back to main, those working directory changes that I have are still there. So I didn't destroy any of the state in main by creating this new work tree to work on a new idea. I kept all of my working directory changes, and it's really easy to switch back and forth and just change context without losing any of my place. Now let's say I have yet another new idea, and so I'm going to create a new work tree, but I'm going to do it inside of GitKraken desktop this time. So I'm just going to click this, going to add a new work tree. I'm going to start this from main again, and I'm going to call this another idea. So I have yet another idea that I want to work on, so I'm going to create another work tree. Let's do that inside of GitKraken desktop this time. If I come over here into the work tree section and I click on new work tree, I can start this from main, and I can say that this is another idea. And so now GitKraken is going to create that work tree. It's going to open it, and now I am on another idea. So I've got three work trees going on here. I have the main work tree that has those working directory changes that I started with. I had this new idea that I wanted to work on some other things on, and then I had yet another idea that I spun up a work tree for. So now I can make some changes there. So let's say that we're going to do that. I'm going to go open this repository in VS Code, and you're going to see that it has opened up a repo that looks like it's called another idea, but it's just the directory that's within the VS Code repository. And I can show that if I come over here into source control and I show you in GitLens the actual work tree section. Let's minimize these. And so you can see the same thing in GitLens here. I have that main work tree, I have the new idea work tree, and then I have another idea. So I have all of these three working directories that I can switch between. I can do the same thing here in GitLens and switch to new idea. So I can switch back to my main work tree. And you'll see that I have those working directory changes again. Those didn't get lost. They still exist. And I can always switch back to any of my other work trees. Let's open up another idea. That's going to open it back up again. And I can start coding, make changes on that one, commit them, push them, all independent of that main branch. So another example, let's say someone opens a pull request and they need your review really quickly. You don't want to block your team, and so you want to switch over and review their work. Now I'm going to put myself back on that main work tree so that I do have those working directory changes there. You can see that I have those files changed. And this time I'm going to go into GitKraken desktop just to show you the Launchpad feature here. I'm going to switch over to Launchpad, which is a good place to go if you want to see which pull requests or issues are assigned to you. And I can see that this issue right here, search for GitLab PRs in Launchpad, was assigned to me. I should go review that. Now, if I want to review it, I can check it out in a new work tree. And instead of having to stash away the changes on main, I can check out in a new work tree. It will keep those changes alive and well in main, but create a new work tree for me to review these changes. So I'm going to come in here. I'm going to create this work tree. It is automatically going to name the branch based on that PR. And I'm going to open it. So now you can see that I'm on this work tree that's named after the PR that I'm on. And so I can come in here, I can review the code. I can go through my review. And when I'm done, I can submit that review to GitHub and then move on. I can close where I'm at, go back to my other work tree. And since I'm done reviewing this, I can remove that work tree. And now I'm back where I started. I haven't lost any of my work. Everything here is still on main. My working directory changes are undisturbed, but I was able to very quickly jump over and review that PR without messing anything up. If I would have needed to build that PR and run any code against it, I could have spun something up in my terminal to go build it, and it would have kept it completely separate from the work that I was doing here on main. So that's a really easy way to use work trees to quickly go over and unblock your team with code reviews. The last scenario I want to run through is that scenario of needing to do a hotfix. Let's say there's a critical issue that comes up in production and you need to open up a branch to push out a fix as quickly as possible. Well, you could hop into your terminal and you could switch over to a new branch. You could do a git work tree add and give it a name, but you might need to go get the name of whatever that issue is. Maybe your team likes to name your issues the name of, or name your branches to follow a specific naming pattern, and maybe you don't know what that is. An easier way to do that would be to go into something like GitLens. And in the home view of GitLens, we have this feature for start work on an issue. And it's a shortcut to immediately starting a branch or a work tree on a new issue. So I'm going to use that right now to find that bug. So I'm going to search for it. And here it is right at the top. I need to fix an incorrect promo code that went out. So I'm going to click that issue. I'm going to start this on main. I'm going to base it on that branch. And it's automatically going to name the branch the name of the issue. And I'm actually going to create this in a new work tree. So now I have this work tree for this hotfix that I need to do some work on. And if I go back to GitLens, I can see that main is still there. That work tree is still there with those working directory changes. So nothing happened to it. It's ready for me to go back to when I need to. I can come in here into this work tree that I created for this hotfix, write the code, push that code up to production, get the thing resolved. And when I'm ready to switch back, in this recent section, I can very quickly see that there's a work tree on main. I can click it, and now I'm right back into main with those working directory changes intact. Nothing got disturbed. I've pushed that bug fix out to production as quick as I could, and I came very quickly back to where I was without having to stash or commit anything. So those were just a couple of examples of how you can use Git work trees in your daily workflow. We've looked at how you can use it to improve parallel development, so you can work on two branches at the same time without worrying about losing your changes. We've looked at how you can use Git work trees to improve code review and unblock your team by very quickly checking out a branch on another work tree, getting that reviewed, and then jumping back to where you left off. And they're also really powerful in situations where you might need to do a critical fix as quickly as possible. You don't want to think about stashing or committing your current work. You just want to jump over to another thread and get that fix out to production. Git work trees are really powerful. They enable you to context switch much easier than branches and really confidently resume where you left off before you went onto that work tree. I encourage you to try Git work trees on your own. Start simple. Create a work tree just for a new idea like I showed you. See what it feels like to have two sets of working directory changes live at the same time and quickly switch back and forth between those work trees and kind of operate in that multi-threaded environment instead of just a single-threaded branching environment. Thank you so much. I hope you enjoy the rest of GitKon.
When I started developing, I'm too scared to do anything when it comes to a command besides what I know to do for a fact. Robot, like git add, git submit, git merge. As long as I don't do anything else, I'm not gonna delete my code by accident. No, you got to experiment a little bit. I think you got to make a few mistakes.
You gotta do a few forced pushes every now and again.
Yeah, exactly. Don't stress about not knowing everything. There are so many resources nowadays out there. There's so many tools. Be resourceful. Don't be stressed about not knowing everything initially, because if you take the approach of, I don't know something, this is an opportunity to learn, you'll be able to with everything that's out there today, and just don't get overwhelmed with all these new frameworks, new things that you could possibly learn. Just do it one at a time. You'll be fine.
I have to say, like, when you're new to code, it's very normal to waste a lot of time. Well, waste might not be the right word. Spend a lot of time on super simple things in hindsight. So I would say don't beat yourself up over the simple things when you're getting started.
Develop a skill set that is broad, but also in some way deep. I'm reminded of a concept from Valve, who makes a video game storefront called Steam. They had a hiring document that said that they like to hire T-shaped people. And the top of the T is having some knowledge of a huge array of things. Just a really broad knowledge, not just necessarily in software development, in the case of this question, but across like everything that a software business cares about. And then that vertical part of the T is like, you are the person for that thing. It's, if they need an expert on this topic, you're indispensable. Figure out what your thing is, but don't neglect the other stuff too.
Thanks for the deep dive on Git Worktrees, Justin.
Want to get better output from your AI coding assistant? John will explain how adding domain-specific context can make those suggestions more relevant.
Hi everybody, my name is John Feeney, and in this session I'm going to talk about AI coding assistants, and in particular how some organizations are unlocking the full potential of their coding assistants and how they do that. So to begin, I think it's, I just want to say a few words about AI. I think it's safe to say that AI is really transforming the way we work in the world of software development, whether you're an experienced software developer looking for ways to accelerate your work, or maybe you're less experienced and you're looking for guidance and assistance on a solution design. AI is really revolutionizing the way we approach our work and the way we think about it. And the benefits and the use cases, they're well documented. I think they're well understood at this point. So I'm not going to spend too much time on that. But I just want to focus on maybe an area where maybe some folks are not realizing the full benefits of AI. And one thing that I want to kind of zero in on is an interesting finding from a recent survey from Carnegie Mellon University. They, as part of this survey, they reached out to a whole bunch of software developers that they knew were using an AI coding assistant of some sort. And they asked them what their thoughts were, and so on. And what was interesting was, for those that were no longer using an AI coding assistant, they asked them, well, what are the reasons for that? Why are you no longer using AI? And the number one response to that question was, the model just does not provide helpful suggestions. Now, that's pretty interesting. And you might ask, well, what does that mean? What do we mean when we say a suggestion is not helpful? Well, it can mean a lot of different things depending on who you talk to, and it can differ from organization to organization. It could mean that the suggested code is just not meeting the functional or non-functional requirements of the system or the team or even the organization itself. It could also mean that maybe the suggestions are just not in line with our guidelines or with our standard practices. It could mean that maybe the suggestions contain errors. Maybe the assistant is not taking a broad enough view of our application landscape, and so the code is not compiling. Maybe the information's out of date, right? This is actually a common criticism of models. They are trained at a point in time, and they're not always aware of the latest software library versions. Okay, so there's a lot of reasons as to why somebody might perceive a code suggestion as being unhelpful. What I'm going to talk about over these next few slides is how some organizations are addressing these concerns. And if I was to sum that up in like one word, that word would be context. Context is all important when it comes to AI, and to really understand that importance, it's worthwhile to kind of maybe just step back and think about models and the way they work. Now, I'm not going to spend too much time on this, but very briefly, modern day LLMs, they are neural networks. They reason about sequences of data and the relationships between entities within those sequences. And that makes them very, very good at predicting what comes next in a sequence of characters or words. So in this oversimplified example that you see on the screen, you can see that context is really, really important, and it really informs what the output or the response from the model is going to be. So the goal is to really ensure that the context is of the highest possible quality to ensure that we have the best possible response from the model. Now, AI coding assistants, they use models, LLMs, that have been trained on millions upon millions of open source repos. Okay, and they've also been highly specialized to deal with coding tasks, and so they lend themselves very, very well to common coding problems, and they can deliver value pretty much out of the box. I mean, you can straight away ask an AI to help you parse a CSV file, to validate some inputs, create a sorting operation for you, help you write a React application from scratch, and so on. But as things become more complicated, as we get into more kind of enterprise situations, that's where they begin to struggle. So, for example, maybe you're working on a long-lived project. Maybe it's years old or even decades old. Maybe there are lots of interdependencies with other systems. And so that's where some AI coding assistants start to fall down. Okay, so to give you a practical example of what I'm talking about, here we're going to ask the assistant, how do we make a call to the services layer within our organization? Now, with little in the way of context, the assistant and the model is going to attempt to answer this question using the open source software upon which it's been trained. But of course, that's going to lead to a very generic response, something that's really not going to be relevant and something that we just won't be able to use. So what you want to do instead is you want to have the assistant to look at your domain, right? So here we're ensuring that it has workspace visibility is turned on. In tab 9, we call this workspace indexing. And we ask the very same question again. And by having the assistant look across our software domain, it'll be able to pull out code or patterns, if they exist, that answer this particular question or problem. And so here you can see we have a different response, and this code here has originated from our own code base. And down at the bottom, the assistant will tell you as well where it obtained this code. So you can open up the file in your IDE. It will highlight the function from which that code suggestion was derived. So it helps you to also navigate your own code base quite easily. So this is all thanks to a mechanism called retrieval augmented generation. And it's a very powerful way of enriching the context that the model uses to answer questions from the user. And this is a very simplified view of the whole thing, but the point here is that we obtain the most closely related documents to the question or the task at hand. And these are obviously, this is data that the model did not have access to at the time of training. And it is provided to the model to provide a correct and appropriate response to the user. Where do we get these documents from? Well, in the world of AI coding assistants, these are, for the most part, code-related files, right? So classes, modules, JSON files, you name it. and they can be obtained from a variety of different sources. So the most obvious one is from the user's local environment, right? So they have cloned all of these repos locally. They have a wealth of code, and much of it is very much pertinent and related to the work they're doing. So it's a very good source of context and data. You can also connect your code repositories to the assistant as well. These are an important source of context. Many organizations do this because over time they have built large repositories of code, many of them decades in the making. And some organizations find that their developer community, some of the developers are rewriting the same code again and again. And so in an effort to encourage reuse of code and to facilitate discoverability of that code, they choose to connect these repos to the assistant. There are many other reasons for doing this as well. I mean, over time, you may have a collection of highly curated best practices and accredited patterns for solving domain-specific problems, and you may want to expose those as code suggestions to your developers. So that's a very good reason to do this as well. You may want to lessen the learning curve for new team members and folks who are onboarding to projects for the first time. Or I've seen situations as well where some organizations have very large teams that are geographically dispersed and they're not immediately aware of the work that each other is doing. And so by connecting these repos to the assistant, that helps to mitigate against that. So lots of great reasons as to why you would want to connect these repos to the assistant. But it's very important that when you do this, that you introduce code that is of high quality because what you get out of the model is only as good as what you put into it. And so, you want to make sure that if there's any undesirable code in there, any legacy code, that you want to strip that out before you introduce it. And then you have non-code sources of information as well that you can connect to the assistant. And these provide invaluable sources of data and context. So for example, you maybe in Confluence or SharePoint, you may have you might be documenting your applications or your systems and outlining the functional and non-functional requirements of those systems. And so that's really important context as well. And maybe you're using Jira or some other planning or a project and portfolio management system. And, with most organizations, work begins with a change description of some sort in a ticket or an issue. So this is really important context as well. And using a combination of all of these things here actually works quite effectively. So, in this example here, you can see where we're connecting the assistant to a Jira ticket that describes the change that we want to implement. And by marrying that context and that change description with the code that we have in the project that we're working on, this together really can form a very comprehensive and robust solution to the requirement or to the problem. Now, another approach that you can take to ensure that this code suggestions being provided to the end users are as helpful as possible is through the introduction of rules. And so these rules can come in a variety of different forms. Again, you could have a wiki page that outlines all of the different rules that you expect that must be obeyed when it comes to writing code for your organization. You might have some code style guides that you're using for different languages. You may even have past code reviews where there have been very valuable comments and guidelines. All of these things can really be used to provide rules to the assistant. And what will happen is the assistant will include these as part of the context. And these will be used, in real time when providing code suggestions to the user within the IDE. So they act as like a set of guardrails for the code suggestions that are provided to the users. And it also allows the assistant to also participate as a code reviewer within pull requests and merge requests. And so, the assistant can look at the changes being proposed, and then by referencing the rules that you've provided, be able to provide remediation advice for these violations. So very, very powerful stuff. Now, looking beyond context, we have the option of fine-tuning. And this is something that some organizations choose to embark on. And we see it most commonly where there are certain languages being used, niche languages, what I would call possibly legacy languages, maybe even domain-specific languages. But ultimately, these are languages where there aren't a lot of open source examples out there for. And the idea here is that we take a pre-trained model. We want to retain as much of the capabilities that the model picked up during pre-training, and we're targeting layers in that model so that it becomes better at a certain task or language. Again, the same rules apply in terms of like data in, data out. When you're fine-tuning the model, you want to make sure that the data, the code that you're introducing is free of any anti-patterns or undesirable code, that it's of high quality. So that's another option. And this rounds out then the various steps or options that organizations pursue in terms of trying to deliver a highly personalized experience to their developers. So we call this the 4 C's. These are 4 stepping stones. Context is, again, what we see in the user's local environment. Connection is, introducing these repos to the assistant. Coaching is providing rules-based guidance to the assistant. And finally, we have customization, which speaks about fine-tuning. Some organizations are further along in this journey than others, but ultimately here you have all the tools to ensure that your developers are receiving the most relevant and helpful suggestions possible and providing full value. Okay, that brings me to an end. I hope you found this session informative, and I hope it's given you some ideas. If you'd like to continue the conversation, please do get in touch with us. We'd love to speak with you. If you want to talk to us about how we can help with the privacy of your data, or how we can provide a highly personalized experience for your teams, let us know. We'd love to pick up the conversation with you. Okay, thank you, and enjoy the rest of the event.
Thanks, John, for helping folks get the most out of AI in their development workflows.
Next up, Luís and Giorgio from Stradio Automotive will talk about how they use AI for their predictive maintenance strategies.
Hey everyone, it's a pleasure being here today and presenting to you the work that we have been doing over the past years in the field of predictive maintenance. I'm Giorgio, and I work as an AI team lead at Stradio. We work mainly in the field of anomaly detection and model development. And I'm joined today by my colleague Luís.
Hi everyone, so my name is Luís Rosário and I'm a machine learning engineer here at Stradio. I've been with the company for just over 2.5 years, working mainly on model productization and general model maintenance, alongside with other data scientists and data engineers.
Thank you very much. So today we'd like to tell you a little bit about our predictive maintenance strategy at Stradio and how we build a general machine learning framework to detect anomalies in the automotive sector. Let me just give you a brief overview of what is Stradio mission. So Rosário is a early warning system product, particularly suited for public transport operators and commercial vehicles. And what I mean by that is for buses and trucks. The main product consists of AI models and analytics to predict and identify future faults and breakdowns within those vehicles. The idea is to try to detect faulty patterns as soon as possible and to prevent breakdowns and the costs associated with that, and to help essentially fleet management systems to reduce downtime. In this talk, we would like to present to you the main predictive maintenance strategy of Stratio, and in particular what we built in the AI team over the past years. There is a general machine learning framework for anomaly detection. This system can work across different type of vehicles, different type of components and system within the vehicles. Of course, we want to highlight the challenges and opportunities in building early warning system. And finally, we'll also go through our infrastructures and the tools that we use to build a scalable machine learning product. Okay, let's go into the details of our main Stratio anomaly detection framework. And to be able to do that, let's be on the same page, okay? So let me remind you, what do we mean when we talk about anomalies? So in a dataset, an anomaly refers to a data point or an observation that is significantly different from the expected pattern or behavior of that certain dataset. And this already let us understand that to define what is an anomaly, we need to define what is the standard behavior that we expect from something, from a sensor or from a component, right? And this is not always trivial. But there is this relationship between defining what is the standard behavior and then defining what is an anomaly. And what we want to do is to use machine learning models to detect anomalies, and in particular to detect failures in mechanical and electronic systems. So our framework that we develop over time at Stratio works as an unsupervised model. As you know, in machine learning, we have many types of models, of course, but two of the most common are supervised or unsupervised models. We decided to go as a first approximation unsupervised and to avoid providing any labels to our model. As you know, sometimes in some domains, it's very difficult to get labels for a certain particular problem. So we decided to go unsupervised. And our main goal is to create a general model, a general pipeline, okay, where we can detect anomalies across different types of vehicles, systems, and components. So the idea here is to try to build one model, one pipeline for different needs. Let me give you an example. Let's imagine that you want to develop, you want to detect failures in the starter battery system and in the HVAC system. One strategy could be to develop ad hoc models for these two problems, right? So two different pipelines with different data acquisition, different feature engineering, different modeling, etc., etc. We decided to go another route and to try to build something where we can plug in different components, meaning the starter battery or the HVAC, and tuning some parameters, we can use the same pipeline. Why doing that? Of course, because we'd like to have a fast development cycle and deployment cycle, while keeping, for instance, the number of false positive rate low. Before going to a concrete example, let me give you a technical overview of what are the main steps of our framework. So the first step is to define a group of similar entities. For instance, the same client, the same brand, the same vehicle model, etc., etc. Why do that? Because as we said before, to define what is an anomaly, we need to define what is the standard behavior of a certain group of vehicles, okay? A group of vehicles, but also in other domains might be something else. So that definition is really important. Then we need to define the sensors that we want to use. For instance, the oil temperature, the oil pressure, the voltage of the battery sensor, etc. And then we fix some parameters. The second step is, once the model has been trained for that particular rule or component, we can run the anomaly detection pipeline for every component, for every vehicle, for every day. And we'll get what we call an anomaly score. The score will go from 0 to 1, essentially. And that will give us an indication of how that component is performing for that vehicle on the considered day. Finally, the last step is that for every vehicle with a score above a certain threshold, we can open a case to be reviewed by our analysts, or we can send it directly to our clients. But to make things more concrete, let me give you a real-world example. It is the following. It's a one-dimensional example, so we have only one feature. And the feature comes from the oil temperature of our vehicles, of the vehicles in our fleet. Okay, so what you are looking at here is the distribution of the oil temperature for all Mercedes 0500 and for all Iveco Crossway. Okay, and in particular here we are looking at the maximum value of the oil temperature over 15 days. And as you can see, different groups gives us different distributions, right? Because look here, we have an average of around 106, 107. While here we have an average that's going to be around here, 94, 95, 96. So you can see that different groups have different needs. And what is an anomaly for the first group might not be an anomaly for the second group, right? Because in this case, a temperature above 115, 120 will be flagged as an high score. Well, here a temperature above 100 or 104 has to be flagged as a high score. And this is very different from a fixed static threshold. Imagine that we decide, okay, all values around above 110 are anomalies. This doesn't work, right? Because this can give us a value here, but here it's not even in the range for the data of this vehicle. And one could think that we can apply a fixed threshold for every group, but that's too expensive in terms of analysis and in terms of study of the different groups, right? So we want to build a machine learning model to detect what are the anomalies for the different groups, okay? So that's what we do here. The Strato Anomaly Detection Framework detects anomalies across different groups. And what is the output? So once the model is trained over a certain historical data, we can use them on a daily basis for every vehicle. And the output of the model is a score from 0 to 1 for every vehicle for every day. And 0 represents a behavior that is very common, while 1 represents a very anomalous vehicle in respect to peers. Okay, so of course, this should we have more vehicles that behave in a good way, let's say, and few vehicles that behave in a strange way. Finally, for every different rule, we can fix a threshold, and above the threshold, if a vehicle goes above the threshold for the day, an alert is sent to the client, so for review. For instance, we can set it at 0.9, and then this threshold can be changed over time, depending on what we need to achieve for that particular rule. In our example here, we have different averages for different groups. The distributions are different. The model understands that and understands that what is an anomaly for the first group might not be an anomaly for the second group, okay? So vehicles with very different behaviors from peers are flagged as anomalies. This is a one-dimensional example, but of course it can be generalized to multiple sensors. For instance, we might create a rule with the oil temperature, with the oil pressure, with the engine RPM, and create a more complex and broader vision. And in that sense, what is an anomaly will be discovered in a multidimensional feature space. Some examples of what we already have and productized rules are, for instance, the starter battery that I mentioned before, the HVAC system, oil temperature, oil pressure, or the emission system with the DPF. Now, how do we productize this pipeline, and what are the tools that we use for that? I will leave the word to Luís.
Okay, thank you, Giorgio, for your presentation. So I will do a brief overview on how we are productizing this pipeline. We chose to use this orchestration framework called Flight. It offers us a way to build modular code grouped into workflows and tasks, being grouped inside of workflows as a smaller unit of code. It allows us an easy way to scale our code according to our needs. It offers also failure recovery and a great deal of observability functions that we can then introduce into every single step of the framework and of the pipeline that allow us to understand what's happening inside the code. Finally, it also allows us the way to use either Ray or Spark via plugins, which is a great plus. So I'll just go over how we have the actual pipeline structured. Since we are dealing with a monorepo for the pipeline, we define a model or a rule as a YAML config, depending on which PID sensor data we want to fetch according to the actual rule that we are building. So the second step is actually fetching the thresholds that we set for every single vehicle inside of every single partition, being a partition, as Giorgio defined, a group of vehicles for a specific brand or model. We have two different thresholds set, one that is for predictions that have a critical value and are most likely a failure, and a lower threshold that allows us to send cases for an analyst review so we can better understand if the model is working properly and double check our values. So the rest of the pipeline is a generic machine learning pipeline, if you are familiar with that. So you have the raw data collection step, then we do some feature engineering on these values, and finally the training or inference stage where we actually get the score and the prediction of the model, then followed by the actual persistence and sending out these predictions to our clients. Okay, this is the actual landing page that you see on flight once you check a specific run. Here you can highlight several different steps of the pipeline, and you can drill down to see by task specific information. For instance, the runtime on on each step. You can go a bit further down and into more detail with that as well. So we finally we are going to talk about a bit of how we are using the flight's capabilities on observability into our favor. We introduced them into separate steps of the pipeline. For instance, on the final step on the prediction stage, we can see on the left a brief summary of how the run went, which type of predictions we generate, and the actual amount, total amount, and we can see if there is probably a problem during our run by just looking at this. Here's another panel to the right where we can see the overall distribution of the scores for this run. Flight also allows us to use inject tables and other type of graphs into this functionality, which is very useful. So regarding how we actually have this deployed infrastructure-wise, and how what is our development flow, mainly since Flight allows us to run our code locally as it was for a regular Python project, the analysts build rules using that, and they can, when they are happy with the final product, we introduce GitKraken to manage our commit labels. Once we generate a label with a specific format, for instance, if you are releasing a release candidate tag, this will be checked by our CI/CD pipelines from GitLab that then will send out the actual deployment into our staging cluster, if that's the case, or our productive cluster. Yeah, that's pretty much the workflow that we are using, and it's been it's sped up the capabilities of our deployment in a great deal. So yeah, thank you.
Thank you very much, Luís. And just to conclude this presentation, we want those are the main takeaway from this presentation. At Stratio, we do predictive maintenance, and we built a general anomaly detection system that is suitable and compatible with different system and components, as well as for different type of vehicles and operations. We productize this framework using Flight and with the help of GitKraken. So thank you very much for your time, and have a great continuation of the conference.
Thank you, everyone.
Really interesting work going on at Stratio. Thanks for sharing, Luís and Giorgio.
To wrap things up, Mike will share how Docker's ecosystem drives developer empowerment in the generative AI era.
Everybody out there, hope you're having a great conference. Really excited to talk to you today. I want to thank the folks at GitKon for putting this together. They've been amazing virtual hosts, and I think they've pulled together some world-class content. I'll start by giving a little introduction about who I am. My name is Mike Donovan. I'm a VP of product at Docker. And my background is actually much more in engineering than product management. So I spent a better part of my career, 15 plus years, as a full stack engineer. My academic background is computer science. And throughout that career, I found myself really gravitating towards product management, helping users solve their problems. But my focus in my product management career has really always been about building great developer tools. Maybe it's because I'm a little selfish and I like to build tools for myself. But I've been having a great time doing it in my career, and especially at Docker. When I'm not doing anything in product management or dev tools, you can probably find me swimming, biking, and running, usually in that order. Love to run triathlons. It's become a hobby of mine. If any of you are interested in discussing triathlons, would love to do that as well. Today, I'm here to talk to you about how we at Docker are driving developer empowerment in this new GenAI era, and we're doing so through the tools and ecosystem surrounding Docker. So let's get right into it. It's probably no surprise that my talk is focused on GenAI, but let's really ground ourselves in why that is. We're seeing record levels of investment being made to build out this GenAI marketplace. Tons of money is going into it, and the majority of that investment so far has been in infrastructure. Really no surprise on that, but what we're seeing is a quick shift towards application development. Now at Docker, we obviously have a pretty special focus on container technology and its impact on application development. And something that's abundantly clear to us is that containers and the ecosystem around containers are playing a critical role in the development of GenAI applications. All kinds of developers are using containers to package, distribute, and scale GenAI applications in a secure and consistent way. And like major technology shifts of the past, there's a lot of these changing happenings which create both challenges as well as opportunities. Now, one such shift from this has been the specialization happening in engineering. I think it's helpful to look at this across the spectrum, from data science on one end to application development on the other. Now, for many years, the development of AI applications really required a team of ML researchers, data scientists, machine learning engineers, and then it also meant you had to throw that output over the wall to a team of full stack engineers who would eventually productize it. Now, I personally remember being on many teams and making a lot of decisions about big bets we would make for data science projects, where we would have an entire team of data scientists go off for 6 months at a time, not knowing exactly what we would get on the other side of it, but knowing it would be worth it. But then whenever that output came, it would be thrown over the wall to another team who would struggle to prioritize it in their backlog. And when we did, it would have a great impact, but the time to value was always so long. And back then, before ChatGPT really shocked the world, I used to believe that the future was really all about data scientists becoming more like full stack engineers, learning different skills around coding and design, product management skills along the way. But it seems like I was really wrong, because we've started to see a democratization of sorts, right? Where there's this new specialization of engineering being created that is dubbed AI engineering. Now, these engineers have a lot of the same full stack skills, but not really that many of the data science skills. It's not necessary because of the technologies that are out there, but they are becoming experts in the tools, the frameworks, and the infrastructure needed to build those GenAI applications. A comparison I love to make is one to the rise of mobile app development. Here on the screen depicted is the number of apps available in the App Store over I think a 10-year period really that reflects the rise of the mobile app development market. More apps meant more development was happening. There's a lot throughout that period. Not only did the number of apps grow, the number of developers grow, but there were a lot of other changes that happened and things that happened over the course of that timeline that were extremely difficult to predict early on. I mean, nobody could really predict what would happen, but we saw so many changes happen, right? We saw big companies fail to take advantage of massive trends in front of them. I'm sure we all remember Microsoft and Bill Gates saying that nobody's going to walk around with a computer in their pocket. I think they were wrong about that. We saw the proliferation of different devices. I'm sure some of you remember the Amazon Fire Phone. We saw the battle between closed and open ecosystems, the Apple versus Android. We saw new programming languages get invented. We saw the creation of hundreds of new operating systems be created, all kind of founded off of the Android open system. And most importantly, we saw brand new user applications built that we would have never dreamed of 10 years ago. And that's really what fueled the application development careers all over the place and the specialization in mobile app development. And the point here is really to reflect on this trend in relation to the trend we're seeing now in GenAI development, because we're in the early innings of this transformation, right? ChatGPT only came out a little over 2 years ago. And so if you think about this in comparison to the mobile app development trend, we're really early on. But I think one thing's for sure is that every transformation that happens more quickly than the last. Now, one of the things we're finding at Docker as we work with our users and our customers is that there are still some constants in the GenAI development world. And those constants are founded in the key areas causing pain for engineering organizations. Many of these pains are the same pains that engineering organizations have experienced in previous waves of technology. Some of these might even sound familiar to many of you that you deal with all the time. These pains are around creating a high-quality developer experience, right? Which, if you do that, improves your velocity, your rate of innovation, and really important, avoid the toil that's involved in a poor developer experience. The next pain point is around developer choice and creating efficient workflows and processes and tech stacks without creating too much tool sprawl, right? Which then becomes really impossible to manage. Then the final area of pain really is about risk management, right? And this could be risk management from a quality perspective, as well as from a security perspective. And securing your supply chain is a really big challenge for organizations, especially in the GenAI era. Now, our focus at Docker, as we look to help mitigate those pain points, is in the inner loop, right? We call this the inner loop that we help developers in shipping superior code. Now, by inner loop, this really means all the activities that a development team does to build, test, and push code. And we believe that by focusing on improving the inner loop, we can positively impact those areas of pain we just described. So our focus is to help empower teams in this new era of GenAI development. And we're really finding some challenges and opportunities within the inner loop that we can impact. And this is what we'll focus on for the remainder of the session now. There's 4 main areas of challenges and opportunities that we're going to dive into. The first challenge is around discovery, right? And this has to do with the challenge that developers across the world face by identifying the right tool to use in a crowded landscape of tools, frameworks, and technologies to choose from that's really growing at a really fast pace as new technologies are being created in the GenAI era. The next challenge we'll talk about is the steep learning curve that developers face as they try to use these new tools, right? They're not only new tools and technologies, but they're new entire concepts that are introduced, and they're being introduced rapidly as research grows. And it's difficult to really understand for many of the engineers. It's not all challenges, though. There's some opportunities that are created. First opportunity we'll talk about is the creation of Copilot technologies, or assistants that can really help developers innovate at a faster clip and improve their daily lives. And then the last opportunity we'll talk about are agentic workflows. And this is really a new way to think about how to build applications in a non-deterministic way that I think can really shape architectures for years to come. So let's dive into each of these. First challenge we'll cover is discovery. Now, this isn't exactly a new phenomenon that there's a crowded landscape of tools for developers to choose from. But I do think that GenAI is amplifying this issue with all the new categories of tools being created, all the new companies that are emerging that are trying to solve problems in these categories. Old companies building new technologies, net new technologies being created and invested in, all of them fighting to win over developers to adopt their tool. And each of these tools, not only are there a lot of them, but they all come with a learning curve because it's a new type of technology to learn about. I mean, a great example is the idea of a RAG application, right? A RAG was something you washed your dishes with a year ago, but now it's an entire new way to build applications that developers are having to learn about. Now, thankfully, helping developers solve this type of challenge isn't exactly new for Docker, right? We've been helping developers sift through the vast landscape of options for years through Docker Hub, which is the world's largest container registry. And we can already see the impact we're having in the development world. So on the screen here, you can see the massive growth of developers pulling images from Docker Hub. And what that means is they're downloading images from Docker Hub when we say pull. And specifically, we're looking at the AI ML category of images available on Docker Hub. In this category alone, we're seeing over 130% growth year over year in the amount of downloads that are happening for AI ML images. Normally, we'll see it for other types of categories like databases or orchestration tools or messaging queues. We see like a 20 to 30% growth rate, very healthy, but that's usually a reflection of just the rate of adoption of container technology. But for AI and ML, we're seeing this explosion in growth. And I think that clearly shows we're serving a need in the market where developers are trying to understand the landscape and adopt the best tools. So we decided to double down on this and help even more. And so in that effort, last month, Docker Hub launched a brand new experience that we call the GenAI catalog. Now, what is this? It's a curated list of the top 30 to 40 images that you as a developer should know about when pulling and building GenAI applications. It includes everything from models, databases, orchestration tools, workflow tools, and full end-to-end developer frameworks to use. We also added support for Docker Compose files as a first-class citizen in Hub, which serve as a really great and easy way to get started with examples of full applications that depend on a lot of different frameworks and tools. You can go to hub.docker.com today and experience this right now. Love for you to go do that and love for you to hear your feedback. One of the crucial parts of the GenAI catalog I mentioned was models that are available on Docker Hub. These models are all deployable. Importantly, they're all deployable as containers, right? So it's a runnable artifact as the model. Comes with the inference API as well. We've partnered with many model publishers on this, including IBM, who've been creating the innovative Granite models, as well as Upstage and their Solar LLM models, and many others. We've been extremely excited to see how well containers work to create those optimal environments to run and scale models in a secure way. And those models available in Docker Hub serve as a standard to build that future on top of, where containers continue to play an important role. The next challenge we'll talk about is the learning curve. Now, similar to the challenge with understanding a vast landscape, learning curves are also nothing new for developers. I just think GenAI applications and tools happen to be a very steep learning curve for multiple reasons. The first reason is due to the difficulty in configuring all those tools and frameworks and services to run in your local environment or in higher environments. For a lot of developers, it's the first time that they're using machine learning libraries that are maybe optimized for very particular hardware configurations. And this kind of leads to that next challenge, where maximizing the applications for particular hardware requirements and optimizing them is a really difficult task for developers who haven't done it before. Many have been hardware has not been a main thing that they've thought about. And there's a lot of nuances and differences between running on NVIDIA GPUs versus AMD GPUs or Intel hardware, and ensuring your container has access to it and is optimized for running it. That can require expertise that not everybody has, really increasing that the steep learning curve. Now, how have we solved this? The first part of our solution goes back to what I mentioned before about the Docker Compose stacks available in the GenAI catalog. It's one of the main reasons why we introduced them, because it allows for the abstraction of all that complexity within the Compose file. We call these stacks because they serve as a full stack application that really helps you get started very quickly and encapsulates all the different hardware configurations. All you have to do is run Docker Compose up. The second way we're helping solve this challenge is through our Docker Desktop and NVIDIA AI Workbench integration. So this really represents a collaboration that enhances that installation experience of what it takes to get started building AI applications. Now, for those who don't know, AI Workbench is a developer tool that facilitates development, management, and collaboration across different platforms, with a particular focus on making GPU interactions straightforward. By embedding and integrating Docker Desktop more seamlessly into the AI Workbench, developers experience a smoother and more efficient setup process, installation process, and it eliminates the switching back and forth between different environments to build your application. The final part of our solution has to do with building out many more new experiences within Docker Desktop to shorten that learning curve for developers. Soon in Docker Desktop, developers will be able to explore that same GenAI catalog right within Docker Desktop without having to leave or navigate away to the web. It'll also include those Docker Compose stacks, making them even easier and simpler to run. We're going to be investing in new one-click to run experiences that abstract even more of the complexity away, with getting up and running with a GenAI model ready to use. And finally, we're going to be exploring integrations with various cloud environments that'll make it possible to experience running GenAI applications on the best hardware options available. This will be especially useful for those developer laptops that lack all the great and latest GPU capabilities. All right, so now that the challenges are behind us, let's discuss those opportunities we see being created in the era of GenAI. First one we'll talk about are copilots, these assistants. Now, Docker has partnered with GitHub to create an extension to the GitHub Copilot that enables some really powerful developer activity. What this allows you to do when you add the extension to GitHub Copilot allows you to easily create all the necessary Docker artifacts and understand Docker technology right within the environment that the developer's coding in. Helps you write things like Docker files, compose files, helps you assess the security risk of the container you're building. And critically, it standardizes a lot of the best practices that only the most advanced Docker users end up learning, but now you get to speed up that learning process by encapsulating all the best practices. And what that really does is enables developers to focus on innovation instead of learning the nuances of how to write, the best and most optimal Docker file. The other impact this has is helping to rapidly containerize more and more applications, especially GenAI applications, which helps to ensure a consistent experience from one environment to the next. Now you can do a lot with the Docker extension for GitHub Copilot right within the developer's coding environment without switching tools or disrupting their flow. You can do things like initiate a conversation with the extension by easily just writing @Docker to trigger the agent. The agent's powered by the Docker documentation, which allows you to ask questions of all kinds, from as simple as what does it mean to containerize an application to something more advanced, like how do I start a container with a volume? It allows you to generate the right Docker assets for your project, helps you containerize your application very quickly, writing a Docker file for you, a Docker compose file for you, and again, using the best practices encapsulated right into the agent. And it also helps you secure your applications from the start. We've integrated the extension with Docker Scout, which is a great way to secure your container applications from the beginning and make sure you're using the most secure dependencies in your application. So I've said a lot about what this extension does. Why don't we take a look and see it in action?
So I'm on github.com and I've got a repo with a React front end, Spring backend, and a MySQL database. This repo isn't yet containerized, but Docker can help us with that. The Docker extension for GitHub Copilot is helpful for existing Docker users and folks looking to learn about containerization and get started. So let's start by asking @Docker about containerization. So I'll type @Docker, can you tell me about containerization? What are its benefits? And so it looks like it's printing out a bunch of different benefits of using containers, which is awesome. And that all sounds super useful. So let's ask the Docker extension for GitHub Copilot to containerize our app. So I'll type @Docker, can you help me containerize my app? So let's see what it did. So, okay, oh great. It generated a couple of different assets and also provided us with some explanation of what each file does. So we have a Docker file for each of our services. So we have one for our front end and one for our back end. And it looks like it also successfully detected the languages for each of our services. So, and if we click into these, we can also see that each of the files is using a multi-stage build, which helps with both optimizing things and improving the overall readability and maintenance of each file. So that's awesome. We also have a Docker compose file, which is really great because that'll help us spin up our app end-to-end in containers, which is really nice for our local development scenario. Oh, and it looks like the Docker extension for GitHub Copilot is also asking me if I want to open a PR. And so I'll say, yeah, let's open a PR. And so it looks like it opened a pull request for us with these assets. We have a nice pull request comment here, which helps us orient ourselves. And then if we click in to see the files change, we can see that it added 2 Docker files, one for our front end and one for our back end, a compose file, and a couple of Docker ignore files, which is awesome. But let's imagine that I'm new here, and let's see if Docker can tell me about how to use these files. So I'll type @Docker, how do I use these Docker files in the Docker compose YAML file? Awesome. And so with a full integration of docs.docker.com in the Docker extension for GitHub Copilot, it's actually telling me how to build and run my application in containers. So as a new developer, this is super, super useful. Okay, one last thing. Integrating security early and often in the development cycle is crucial, and that's precisely what Docker for GitHub Copilot will help us handle. Using the Docker extension for GitHub Copilot, we can proactively manage security issues with output powered by Docker Scout seamlessly in our Copilot chat. So let's see that in action. So I'm going to type @Docker, can you tell me if I have any vulnerabilities in my project? And using this simple prompt, we can see that I do actually have a couple of vulnerabilities to fix and instructions about continuing to use Scout in the CLI. And that's pretty much it. We saw the Docker extension for GitHub Copilot help us learn about containerization, generate Docker assets to containerize our app, teach us how to build and run Docker files and compose files, and help us find security vulnerabilities in our project. We'll be adding more capabilities in the extension over the limited public beta, so stay tuned.
I love seeing the Docker extension Copilot in action because I know how helpful it's been for so many users as one of the most popular extensions for GitHub Copilot available. Definitely recommend giving it a try if you haven't already. Would love to hear your feedback. Now on to the last area of opportunity that we see in the GenAI era. And this is one I'm personally really excited about, called agentic workflows. It's a fancy name. I'll describe what it means. This all came about from our exploration in through GenAI application development, right? And it's something we started about a year ago through the Docker GenAI Labs project. Now, what this is, it's essentially a set of blog posts and code bases, Visual Studio Code extensions, Docker Desktop extensions, and they're all exploring the boundaries of what's possible with GenAI. At the end, I'll post a link to the project so you can read more about it, right? But each mini project within this series are basically attempts to accomplish a meaningful task with GenAI. It's kind of like we go on a mission each time and see if we can have GenAI accomplish it. For this particular one we're going to walk through, the mission was focused on generating a Docker file that was useful, so that could be used without any human interaction. And to do this, we essentially were using tools and large language models to talk together to achieve this outcome. Now, most people know it's pretty easy to go and ask a large language model to generate a Docker file, or really any code for that matter. But in my experience, and I think it's definitely getting better, but in my experience, some of that code is rarely useful without a lot of heavy manipulation, especially for more nuanced tasks, like writing a Docker file for your specific application. So this is where agentic workflows came in, and we really tried to create this interaction without a human in the loop. Now, when we say the words agentic workflow, it really comes down to a fairly simple concept where you're enabling a large language model to invoke a function that you define when it should be invoked and under what context it should be invoked and what the function does, right? This is often referred to as tools in the OpenAI API spec. And it's a pretty simple interaction where your application will, start the process by calling the large language model, providing context of what are the functions it can call and under what context does it call them. Then as the model is achieving the prompt that you gave it, it decides whether or not it should respond by invoking the function call. The function, when it does decide that it needs to call the function is called, and the response of the return of the function, the response of the function is returned to the large language model, and then it keeps going until it fulfills the prompt. So for this, I think it's important to maybe start by looking at the architecture that was built to accomplish this task. There's a couple important pieces here. The first they'll talk about are the tools itself, right? And so remember, these tools are really just function calls. There's 3 that we created, one function call to analyze a project, another to write a file, and another one to make a scout recommendation. An important point to note is that each of these tools are encapsulated as runnable Docker containers. And they're all then registered with the large language model as a tool to call under certain contexts. The other aspect that's important are the system prompts. Now, these are additional context that's fed into a large language model. And what this does is it dramatically improves the output of that large language model because it encapsulates a lot of the best practices of how to create Docker files. There's also a large language model with an OpenAI API compatible interface for running inference. And then there's a client, and the client is actually plays a fairly simple role here because it just needs to start the process. Now, this all was able to be accomplished. This architecture was able to accomplish the goal. And I'm going to walk through the conversation loop that happened between all the systems involved here, because there's some very interesting takeaways that happen when you walk through it. So let's go through step by step in how this was executed. All right, the first part is a system prompt, right? Letting the assistant being fed into the large language model, which tells the assistant that it's a specialist in writing Docker files, and because of that, it should be pretty definitive about the recommendations it makes, giving the model a little bit of personality to start with. And now the user begins this process with that first prompt, right? And the first prompt being to analyze the project, to determine how it should be built, and then once that analysis is complete, you're going to create a Docker file to build the project. Now, this is the first key takeaway I have when looking at how to accomplish the goal, and that is one of decomposition, right? Now, the goal that we have is to create a usable Docker file without a human in the loop. That's not the prompt we give the large language model. Instead, we decompose the problem into its 2 important steps, which is, okay, well, if I want to write a Docker file, I need to know what kind of project it is that I'm writing a Docker file for. And then once that analysis is done, I build then you can build the Docker file. So decomposing the problem into its subcomponents, really important step. And so because of that prompt, we move on. The large language model responds back first with a function call, because I told it to analyze I said the first step is always analyze the project. It will then return back with a call to a function. So the code received, our client receives that and invokes the function automatically, and it says this is an npm project, right? It looks for certain files in the project and it lets it know what it is. That's great. Moving that, the response then gets fed into the large language model that it's an npm project, and another system prompt kicks in. And this system prompt contains all the encapsulates all those best practices for how to build Docker files. It's important to dive a little deeper into what those best practices contain. Right, this is defined by us up front, and it's useful for generating any Docker file. But it really is it's talking about what are the best practices for writing an npm project. And it has some pretty complex things in here that are really best practices that we've learned over many years of writing npm Docker files. Things around what kind of flags to use, how to run a multi-stage build. And then it even has instructions in here about calling Docker Scout in order to get recommended tags to use, or recommended versions of images to use as a dependency. So this is that other really key takeaway, is that these system prompts are used to encapsulate knowledge that you've built up over the years, so that every time you invoke the large language model, you're getting the best output possible, and not just throwaway output that eventually has to be rewritten anyway. All right, back to the conversation. So the system prompt had all the best practices in it, and because that best practice did include a recommendation, an instruction to use Scout under certain circumstances to call that function, then that's exactly what happens. It returns back with, okay, first I need to call a function to get a Docker Scout tag recommendation. Function call happens, and it returns back a recommendation to use that particular image tag. With that in hand, now the large language model can generate the Docker file and do the last step, which is to write the file. And so it's making another function call where the body of the file is the Docker file to write, and it's going to call our function write files. Great. Now, function call happens to write the file, but an error happens. This doesn't happen all the time, but in a couple cases that we noticed, it executed an error. Now you think, and this error was because of a syntax error with the JSON file. You might think that it would just end right there, but what's very interesting is what happens next. In that, that the response from that function call is returned to the large language model, and so it says, "Look, I'm sorry, I didn't mean to make an error. Let me try it again." Reformats the JSON file, calls write file again. This time it's successful, and it actually wrote the Docker file following all the best practices. This is another key takeaway here. The fact that it was able to, first of all, experience an error means that sandboxing those function calls using containers, really important to limit the blast radius of any error that happens. But also the reliability of this whole kind of an architecture is really key, so that it can rerun failures and recover. At the end, though, going back to the conversation, it figures out that it wrote the Docker file, the goal was achieved, and the conversation ends. So to summarize some of those key takeaways that we found while sort of building out this system and accomplishing that goal. Number one, the prompts really do encapsulate all that domain knowledge that you've built up over the years. By doing that, you dramatically improve the output of the large language model. We also saw how containers play a critical role in building a system like this, because it really creates that sandbox environment, enabling you to be very flexible in your deployment, but also secure and limiting any blast radius of any issues that might happen. We also saw how decomposition is really key, and how you have to really break down the problem into its subcomponents in order to have the goal accomplished in the way that it should. Those components that we broke it down into were the different function calls that would generally happen, as well as the prompt and instructions to the LLM. And then finally, we saw how important reliability is, because mistakes are going to happen. I mean, humans make mistakes, and so do these agentic workflows. They have to be able to recover from them. But I think it's amazing to see that it is able to recover. Okay, so that was a lot. We covered a lot. Just to recap, we covered a couple different challenges and opportunities in the GenAI landscape. First challenge was around discovery and helping developers sift through the massive landscape of tools available to them. We showed how Docker Hub helps you do that with our brand new experience around the GenAI catalog. We also talked about the challenge developers face with the steep learning curve when they do find that technology or framework or service to use. And it's really hard for engineers to understand what those new technologies are, and we're helping them get past that learning curve and learn things quicker through our Docker desktop feature set and the integration with the NVIDIA Workbench, as well as through the availability of Docker Compose stacks that just help you get up and running really quickly, abstracting away a lot of the complexity. We also saw how the opportunity that's created by the existence of Copilot technologies and coding assistance, and how that can drastically reduce the amount of time spent on getting up to speed with different technologies, and just removing a lot of the toil from the developer workflow. We saw how Docker has created the the Docker extension for GitHub Copilot that's helping many developers write their Docker files, write their Docker Compose files, and just learn about how to containerize their applications very quickly. And then finally, we saw how new types of non-deterministic applications are being built using agentic workflows, and how containers are playing a critical role in defining the architectures of the future. So before I leave you, I want to leave you with some ways that you can get started and engage with a lot of this material that we went over today. You can find that link to our GenAI Lab series that goes into many more examples of how to use GenAI technology to build new types of applications. You have a link there to our GenAI catalog on Docker Hub. And then you have a link to the GitHub Copilot extension that you can start playing with now. We'd love for you to engage with all of these. Get in touch with us, send us feedback. We love hearing all of it. And I just want to say thanks again to GitKon for doing this and for all of you for paying attention. Looking forward to connecting over LinkedIn and any other place. Please don't hesitate to reach out. Bye.
And that's a wrap on GitKon 2024. Thank you all so much for joining us over the past 2 days. It's been an incredible journey through the latest in AI, DevEx, and the future of development.
We hope you enjoyed this year's sessions and are leaving with some fresh ideas and practical takeaways.
And remember, the conversation doesn't stop here. All sessions will be available on demand on our YouTube channel, so you can rewatch your favorites or catch anything you missed. Plus, stay connected with us on social to keep learning and sharing with the GitKraken community.
Thank you again for being a part of GitKon 2024. We had a blast putting it together.